Hello everyone, and in this chapter we will learn about the DCS overview. So basically DCS is the distributed control system, where the control system is distributed and it is not centralized at a single or on a single controller or on a single algorithm. So basically the controls, if you have multiple areas in your plant, so you can put several controllers and several automation systems spread out in a large geographical area as well, and then you can see all those parameters and you can control it from a single console or single HMI or workstation, operator workstation, engineering workstation, but the controls are distributed, so processing is happening on a distributed controllers. So this is one good aspect, and it is basically DCS control systems are used in oil and gas industries, energy utilities, chemical plants, manufacturing plants, and pharmaceuticals as well. So where there is some process intensive control loops are running, so though in those areas we basically implement DCS systems, like if IO numbers are very high and it's not a batch process, so it's like analog control loops are quite obvious in the plan, so there we use DCS system. So basically what happens, like in DCS system we will have the field level instrumentations. So those will include like pressure transmitters or pressure temperature measuring instruments or level measuring instruments or even flow measuring instruments. So this is one part, like the measurement part will be there. Then apart from that we will have the command part also. So there will be solenoid valves, there could be motorized valves which receives commands from the DCS and then processes further into the downstream equipments. So this is about the level 0, like this is the basic level, field level, and then all these commands are getting integrated to the controllers via the IO card. So at this level you will see the multiple IO cards will be there, and these IO cards then forwards all those signals to the controller, and then from controller it is being read by the HMI software or the DCS software directly, or there is a intermediate software in between. And all these communications are not necessarily happening in the TCP/IP protocol or in a very known protocol. It could be their proprietary protocol, it could be Modbus, it could be DNP3, it could be IEC 6850. So it depends on all field bus protocol. So the protocol could be different. So communication between these IO cards to the field instrumentation, that protocol could be different. But when we go on the upper levels in the DCS, we will find that our TCP communication is quite obvious. So basically we were discussing about like all these signals are then connected by this controllers, and then these are forwarded to their respective HMI software, and then that software processes those information, and operator can check and configure and program from their respective softwares. Then also we have engineering workstations and operator workstations in our plants in DCS. So from engineering workstation, what we can do, we can program those controllers, whatever it is. If it is a turbine control in a power plant, we can put a new logic into that. We can download a new logic, we can modify the logics, the business logic, what is getting executed. We can do all those graphics tasks, we can do set the archive and everything from the engineering workstations. So basically purpose of engineering workstation is to configure this thing. Then we will have historians also. The purpose of the historian is to save the analog process data or digital process data or whatever we configure, so it saves everything in it. So historian is a big server which has a good storage capacity, or even sometimes historian is just a software and it takes all those data and saves into a NAS drive or a SAN drive on the network. It depends on the what type of DCS we are using. Then we can have the control servers where the actual application server runs. So in case of the Siemens, it's like SPPA T3000 runs on the application server, and then it is getting accessed by the thin clients. So thin clients could be engineering workstation, it could be operator workstation. So this is how DCS system is set up in different plant premises. Now if we go more above, then we will have the operator workstations. So operator workstations have only operator rights, so operator can give commands to the valve. So all the commands related to the process which can impact the process parameters, like changing the drum level, changing the heater level, or turning on a motor or turning off a motor, or putting a system into auto, taking back to the manual, giving the load set point, giving the control set point. So all these type of activity related to the process control. So because the operation people they are more aware of the process, what they want, how to run the business and how to run the plant, they know. So that's why these operator workstations are required, so that they can operate from there. Now apart from the operator workstations, there could be other solutions also, that could be a management server. So management server, like it could be a machine monitoring system, which monitors the complete machine, it monitors the vibration of the system, it monitors everything, other details, healthiness of the system. So those types of management server, we can take backup of the switches from this management server. So basically, if the network architecture is designed in such a way that we can do the management task from a server, then that is called a management server. Sometimes management LAN is also different in some of the plants. So one of the server could be the OPC. OPC is the object linked process control server. So what it does, it gives an interface so that you can communicate to other system, third party vendors also. So let us suppose if you are using a DCS of Siemens and you want to send some data to the ABB solution, it is in the same premise or at a just 100 meter or 200 meter or within the same plant, then you can use the OPC functionality. What it does, OPC is a protocol which converts any other language to a common format, so that everyone understands this OPC, and we can transfer our tax values and other things also. So let us suppose if we want to transfer one process data from one location to another location, then we should and both are the two different OEMs. In that case, we can use OPC to transfer all those data from one point to another point. So, and other types of application servers also, it could be possible. Then yes, in DCS also you might have often seen that some data is also going to the cloud, to MIS, to SAP servers, or to other places. So this is how a generic architecture of DCS looks like in detail, or we can say it's a high level view of a DCS. Then let's see some of the examples of the DCS solutions. So here we can see it is a sample architecture of SPPA T3000. So SPPA T3000 is a DCS solution by Siemens, and this is the name of their software and the solution. So how it looks like. So in the field, it starts from the IO card. So these ETT200 modules are the IO cards, which are connected to a S7 300 CPU. Here in this picture, it could be 400, 410, or some other PLCs also. Then all the automation related things are connected to the automation server. So automation servers hosts this application, and so basically automation server is any type of solution. It could be a AS3000, we can say that as a automation server. It's a CS3000, it can be told as a automation server. In some cases we put S7 also, and that is also a type of automation server. So there is nothing like proper automation server in a rack mounted system. So all these controllers like CS3000 or AS3000 is called automation server. So but there is a separate network of automation. So all these controllers are connected in a network, and that is called the automation highway. Then we'll have the time server also residing on the same network, so that all these devices, whatever is connected, it can be synchronized from this time server. Then application server sits in between. So this application server will have multiple NIC port on the server. So this hardware is basically it could be HP DL360 servers, or it could be Dell servers, or Fujitsu servers. Those servers are there, and on this Windows servers are installed, and top of Windows server the application software runs, and the name of the application software is the SPPA T3000. So that is getting installed, and it is getting data from both the automation highway and as well as the application network. So in application network, what is application network? In application network, there are multiple thin clients sitting on, and from thin clients you can log into this application server and you can access the workbench and you can do all those tasks. So now this thin clients, you can configure this as a operator workstation, you can configure as a guest workstation, you can configure it as an engineer workstation with a different level of privileges. You can define privileges in this software also. So if you deploy this thin client as an operator, it will be deployed with the several restrictions and user can do only the operation related task. And if you deploy this workstation as an engineering workstation, then then the engineer can do the engineering related tasks. So those types of privilege related softwares are getting installed on this system. So this is one type of DCS we can say, and another type of DCS what we can see is a delta V architecture. Here also we can see the controllers are getting connected to the field automation, and these are delta V IO cards, and then controllers and all these are connected to the delta V workstations. And similar type of topology is there. It seems like this is a redundant topology. We can see here also it is redundant. So what is the meaning of redundant? Like in case of the one link fails, other links will remain alive and system will not get down. So this is done for the high availability to avoid the DOS attacks and all those things. So we'll study about these things in our upcoming slides. So these two architectures what we are seeing here, these two are the architecture of the DCS example. So I think for this this is a cybersecurity course. For this we'll not deep dive into the DCS because we'll focus on the cybersecurity. So let's move to the next topic. Thank you. Hello again, and in this lecture we'll learn about the PLC overview. So basically PLC has is associated with the IO cards, so similar fashion as in DCS. So all these field signals will be connected to the IO cards, and then from IO cards PLC will have their own controller, and it is dedicated to one areas only. So we can often we can use one HMI, as well as if workstation is required. Yes, we can attach one workstation. Also we can keep a historian, as well as we can keep the same application of historian on the same workstations as well. So from small to small requirement to a large requirement, also we can see this PLCs. So PLCs are like, we can start with smaller area, but it's not like that only for the smaller area. So where the batch process or where the discrete logic is required, digital logic is more used at those places. We have seen a very large PLC networks as well. So here on the right side we can see there is one example of Allen Bradley PLC architecture. So control logics you can see here, it is an open high source control platform for multiple types of control that can perform sequential logics. It can also control process logics, drives, motions, controls, or any other type of requirements as well. So control logics is a flexible platform, and that allows multiple processors, networks, and IOs to be mixed without restrictions. So as per the requirement, so if it is a very less requirement, then definitely this type of architecture we can go with. But if the requirement is high and application grows, then we can use netlinks architecture also for the control information. So in that case we can define Ethernet, control net, and device net, three types of network as well. So control net controller can also communicate to backplane communication interface modules to monitor and control the IOs on control net, device net, and Ethernet as well. So separate communication modules you need to plug for that if you want to control everything from the control net. But if you have but if control net communication module is available in the same chassis or the control gateway, the control network is an open high speed network used to transferring the data. It provides the real-time control messaging services to peer communication. Then we have device net. So device net is also open low level connection link, and that has a connection between simple process measurement devices like sensors and actuators. So basically device net is the lowest level of communication, and it is getting directly data from the field, we can say, or the control logics can get data via field foundation bus directly from the field. But control net, from here we can control or we can get all those data from all these networks, subject to we have all those required modules. The Ethernet network is on the top, and Ethernet network is the local area network designed for the high speed exchange of information between computers and related. So as in DCS Ethernet protocols are there above level 2 and level 3. So what are these levels? Okay, we'll understand in next chapter, and it will be our upcoming chapter, so it will be easy to understand about the levels. And then apart from this Ethernet, control net, device net, there are other networks also like serial network, field network, and that is also common in DCS also and PLCs also. So basically PLC network is just example of PLC network, and there are multiple examples of PLC network. You can see the PLC related courses for depth. In this we'll just stick to the high level architecture, and we'll see how we can implement cybersecurity measures for this type of network also. So let's move to the next chapter. Thank you. Hello everyone, and welcome to this lecture, and this is about the SCADA overview. And basically I have taken a zonal architecture of SCADA here, so that we will have benefit in the further part of the chapters also to understand what is the zone. But for now, consider zone as just a zone, as in word English, so it's just an area. So let us see what it is. So basically we can see it's a primary substation, secondary substation, DR substation, and household. So all these are connected to some process zone uh, or a SCADA DM zone or AME zone. But one thing you can notice that all these communications are not the wired communication. So it could be a fiber, it could be a GPS or LTE, or a wireless communication. So it's a GPRS or LTE communications, and it is going directly to internet, or we are using a cell tower communication using CDMA or LTE or anything. So this is the major thing in the SCADA, where we use the communication irrespective of what it could be. We can use 5G, 4G, GPRS, LTE, fiber communications. So basically these substations are located at a distant location. That's why we need to use the available communication methods, and those are not like the DCS, where we have the continuous communication. We have the cables connecting from end to end, and also the thing is that a little latency in SCADA will not have much impact. A little jitter will not have much impact, but though we ensure a very fast communication here as well, to avoid any type of mismatch or any type of jitter in the network. So basically this is the high level map, where we can see several zones are there. So let's study about these zones. So there are basically these zones. SCADA zone is there, process zone is there, SCADA DMZ zone is there, then engineering zone is there, then office LAN, public DMZ, DSO WAN, and primary substation, telecom operator, and secondary substation, energy supplier zone. So these are some zones what we can see. So let's go and we'll study some of the zones. So basically SCADA zone, what we see, this is the more elaborated picture of the SCADA zone. So in SCADA zone is the most essential part of the structure. This is where the commands from the operators are delivered and then distributed to actual substations. So basically we see SCADA is taking all the process data. We have HMIs here and time server also for time synchronization. We have similar historian as in DCS. We have maintenance data, and then for the further process we have a communication to the process zones also. Then we have a SCADA DMZ zone, and this means that it is acting as an intermediate zone for the data transfer between SCADA and the office zone. So DMZ, full form of DMZ is demilitarized zone. And why it is called demilitarized zone? Because we do not have a direct communication from this zone to any zone. So here we everything passes through the firewall. So both sides there are the firewall. That's why it is called a demilitarized zone. So in DMZ, whatever communication will come, it will be thoroughly inspected by the firewalls, and then only it will be allowed to pass from one zone to another zone. So it has got connections to the office zone, where the office staff are working with the statistics and the status information, like for instance power outages. And it has got VPN connection. So what is VPN? VPN is virtual private network. It is also a secured connection coming from the outside. So this is done to create a secure channel on the internet or on a public network to the external hardware or software vendor. So basically we discussed here only two zones, but there are other zones also in the SCADA. There are engineering zones we can see in the SCADA. So engineering zone, where the power system structure is defined, where the definition, and this is not limited to only the power industry. So SCADA, yeah, it is most popular in the substation and power distribution, but SCADA can be used in other industries also. So the definition is then fed into the SCADA system and will determine what operations that can be done to different parts of the power grid or the field instrumentation, I can say. So so this is about the engineering zone. Then we can see here DSO. So what is DSO? DSO full form is like distribution system operator area. So distribution operation area can be a dedicated channel only managed by the distribution system operator, or it could be connected by a fiber communication directly. So that is a DSO zone. Then we could have a telecom and operator secondary substations also, so that is connected by the telecom communication. Then we can see one AMI zone also, and AMI zone contains for collector readings of the energy communication from the household, industrial and customers, as well as allowing the office staff to query meter status, and in some environments send switching commands to specific customers when needed. So in case if the smart meters are used, then in that case this AMI zone controls all those communication. Apart from that, there are multiple hardware software vendor zones, then TSO zones, then data hub and energy supplier zones. Also all are connected from internet, and they can take, read or write data as per the rules defined and the policies defined here. So this is how, like, SCADA networks are basically very highly distributed, and communication is also not regular. So communication is also like we can use any type of communication happening. We should not stick to only one type of communication, and that is the end-to-end point-to-point cable communication. So we can use all sorts of communication. We can read any devices. It's not also devices specific, only the protocol. And if the RTUs or the substations, whatever design, those follow the standard designing principles, then any SCADA can read data from the any of the controllers of substation devices and RTUs, you can say. So this was all about the SCADA overview, and we'll also see like how all these systems or all these things are pretty common to each other, so that we can define and design the cybersecurity requirements. So we'll study about this in our upcoming chapters. So let's move to next. Till then, thank you.
and welcome again in this lecture. And this lecture is about the BACS. So, what is BACS? BACS is building automation systems, or we can say building automation and control systems. And these are also type of OT systems, and they are commonly used for in buildings for heating, ventilation, air conditioning, or in short, you can say HVAC, fire, electrical, lighting, physical access controls, physical security, and other utility systems. So, if you see, most of the modern buildings contain some form of building automation systems. It could be a smaller, it could be on the smaller quantum, or it can be on a bigger, large scale as well, depending on the building architecture as well as the type of automation what has been implemented there. So older buildings and equipments may have been retrofitted with new systems. It is also possible, but it is there in almost all of the buildings. So some of the most common functions of building automations are maintaining the environmental conditions for occupant comfort, reducing energy consumption, reducing operating and maintenance cost, increasing security, recording historical data, temperature, humidity, and performing general equipment monitoring. So these are some of the functions of building automation system. So basically, the architecture, control network architecture of building automation looks like this. So they will have a field layer where all those VAV box, air handler, boiler, badge reader, wireless sensor, all the field related equipments will reside. Then we'll have the automation layer where automation controllers will reside. Then we have a supervisory layer where we will see supervisory application setting, and then finally we have enterprise layer at the top. So basically, environmental controller sensors can provide the temperature and humidity to the building controller. If the sensor values are outside the set points, the controller can signal a VAV box. VAV is variable air volume box to increase or decrease the airflow and bring the temperature to the desired state. So similarly, a building equipment scanning their identification badge at the badge reader can result in the credentials being sent to the access controller, and then access controller and application controller server determine whether access should be granted or not. So this type of applications will be there. This type of use cases will be there for building automation systems, and similar type of network segmentation or the cybersecurity controls we can implement for these systems what are available there. So if these are Windows related system, we need to find we need to design a solution which is compatible to the Windows systems. If these are proprietary controls, then we'll need to see what type of cybersecurity controls we can implement. So for building automation systems also, it is a threat to life or health and safety impact as well, because if someone plays around with the BACS system, it can impact the quality of stay at the building. Like if someone increases the temperature, or someone disables the air conditioning, or someone switches off all the lights of the building. So these types of hacks can be happen, or might be possible that someone is utilizing the processing and compute power of the building devices for Bitcoin or crypto coin mining. So these types of attacks we have seen earlier, and we have a reference of all those things. So that's why it is also important to protect this BACS system, as it has all the four things can be impacted, like health and safety impact. It could have the financial impact in case of loss of some of the services, billing services, or the food and restaurant services, or even stay services. Other could be the reputation impact. So if some company, big brands now getting hacked, and they are in the BACS systems, or some hotels or some organizations hacked, so there will be an impact also on the reputation of that company. So this is a like high level overview of BACS, and I think hope it gave you a good understanding that how does it looks like, how does building automation looks like. So it's a simple, and it's just we can say similar to DCS because they have also a distributed control system, and it can be visualized from a central location, and can be managed from a central location also. So that's all about BACS. Thank you. So this topic is SIS overviews. SIS stands for Safety Instrumented System, and safety systems are designed to reduce the likelihood or consequence of these potentially hazardous situations by bringing system to safe state. So what does happen, like there are some critical systems in the plant, or basically in oil and gas or some chemical industries, so we use safety instrumented system. So there are multiple providers, like in Siemens, if you go, you'll find fail safe controllers. In Schneider Electric, there are Triconex, Trident type of controllers and systems are there. So similarly for Yokogawa also there are some solutions. In Immersion also offers some solutions. So all these OEMs, they have a special category of safety instrumented systems, and those are implemented in the supercritical places. So there are several types of safety systems related to OT environments, including emergency shutdown, process safety shutdown, PSS, FGS, fire gas systems. HIPS is also there. So one or more well-known of safety systems is SIS, and SIS system, which is composed of more than safety instrumented, one or more safety instrumented functions. So what is the safety instrumented function? It is an engineered system typically comprised of sensors, logic solvers, and panel control elements, whose purpose is to bring the system to safe state when predetermined thresholds are violated. So they're basically focused on the safe shutdown of the system. If something or some logic has been triggered, or some logic is violated, or some thresholds are met, in that case the main responsibility of these controllers are to bring to system shutdown in a safely manner, not in an abrupt manner. So these are typically independent from all other control systems, so that failure of the basic process control system will not impact the functionality of the SIS in a deleterious manner. So initially SIS were designed standalone and physically and logically separated, also sometimes air gap. Now also organizations are going for air gapping again in some places due to increasing the cyber threat from a connected network. So SIS and BPCS operated completely independent of each other without any communication. Then some modern SIS also, like if you see I from Emerson, so they have like ICSS. ICSS is a basically integrated control and safety systems, and in ICCS solutions, all you can get there will be communication between the SIS and BPCS, or basic process control system sometimes. So that is the ICSS, where the combine the functionality of both control and safety systems. So this is a basic overview of SIS systems, and we need to implement proper cyber security solutions to safeguard our SIS systems as well, because these systems are super critical, and adversary may target, and adversary will target these systems for their enhanced gains and in major impact on the organization. So one thing is that we can air gap the system again, and other that we need to provide at least basic physical access controls. We need to provide all those proven and tested and released by the OEM. So those type of cybersecurity measures we need to implement on the systems. We need to collect the logs from this system to for non-repudiation. So we'll talk about all these cybersecurity controls, but this is the basic architecture what I was trying to explain about the SIS and why it is there. So let's move to the next chapter. Thank you. Welcome back in this chapter, and this chapter is about the IIoT. So IIoT stands for Industrial Internet of Things, which consists of the sensors, which consist of instruments, machines, and other devices that are networked together and use internet connectivity to enhance industrial and manufacturing business process and applications. So this is a standard definition of IIoT. So what I said, that IIoT contains all these field instrumentations, machines, everything networked together to the industrial applications using internet, basically in other terms. So as OT and IoT and OT and IT systems continue to converge and the systems become more interconnected, control of physical processes remains a relatively unique and critical concept of OT. So basically, IoT Consortium is a governing body which controls and releases the guidelines for IIoT. So they have given a three-tier model. So that three-tier model is one of the cloud, or we can say enterprise model, enterprise layer. Then we have a platform where multiple networks could be there, and third one is the edge tier. So where edge devices and everything lies out. And there is a one more segregation that is like similar to that, but it is a layer. So here device layer is there, and which contains CPS, machines, hardware. So all these are in the device layer. Then we have the network layer. So it could be a Bluetooth communication, LoRa communication, cellular communication, or Wi-Fi communication. So that is the network layer where we have established all the communications from these devices. Then we have service layer. So service layer will reside either on the edge or on the cloud. So it could be applications, softwares to analyze data and transform into actionable information. So this is the service layer. Then we have content layer. So user content layer will be on the top in enterprise. So user interface devices, example, computer screens, stations, tablet, smart glasses, smart surfaces. So everything will be in the content layer where user can see all those content. So here one term, if we do not explain what is edge and edge computing, then it won't be useful. So edge computing is a decentralized computing infrastructure in which computing resources and application services can be distributed along the communication path between the data source and the cloud. So if we are putting, if in IoT there is a edge computing, and edge computing is a decentralized computing infrastructure. It is not like some computing is happening at a particular location. So this computing is distributed from bottom to top at each layer. So some computing will happen at this layer, some computation will happen at this place. Only in the network, like where transmission is happening, there won't be anything. But again, when it reaches to cloud, there will be some computing. So this computing is distributed on a on this vertical, so that it is not concentrated at a particular segment. Like in DCS, you have seen that all computations are happening at the controller level. In PLC also, computation is being performed by the controllers mainly. But here what is happening, like even the devices are smart, they are doing some computation. Then edge devices, which is collecting, or the hub, IoT hub, that is also doing some type of computation. Or the gateways, what is receiving data and forwarding only the metadata to the top, to the clouds, that is also doing some computation. Then internet cloud, where this IoT algorithm is hosted, then that is also doing the computation. So at every layers this computation is happening here. So edge is not merely a way to collect data like if we are putting a RTD, a thermocouple in DCS, so that cannot do any type of computation. That is just collecting the data and forwarding it to DCS. But in IoT, it is not happening that. If we are putting a sensor, a smart sensor, then it is collecting some data and it is doing some sort of processing, and then only it forwarded above. So edge is not merely a way to collect data for transmission to the data center or cloud. It also processes, analyzes, and acts on data collected at the edge, and therefore essential for optimizing industrial data at every aspect of the operation. So there are some benefits of IoT system architecture. One, it could be peer-to-peer networking, like security cameras communicated about identified objects. So if one camera has identified anything, it can share that information or that learning to the other camera, so that they can also identify the same object. Then next is the edge device collaboration, like wind turbines in remote locations. They can also do processing and give output to the user in the field itself without going even to the cloud. So that is edge device collaboration. Then distributed queries across data stored in devices, in cloud, anywhere in between. You can access any of the data from there. Then distributed data management, defining where and what data to be stored and how long. We can set like how much data this edge gateway can contain, how much data this edge device will retain. So those can be configured. Data governance, including quality, discovery, usability, privacy, security. So multiple things we can do, because even your sensors are very smart. They have all those compute power, they have communication power, they have retaining, archiving powers also. So all in all, this IoT architecture is booming, and we need to focus on the cybersecurity requirements as well. We need to see what is that attack surface of these environments, and we need to design technical controls as required, depending on the threat actors, threat scenarios, and risks involved in the IoT. So that's all about the IoT architecture. Let's move to the next topic. Hello everyone, and welcome in this chapter. So this chapter is known as Purdue model. So Purdue came from Purdue University, where this research was done, and this is a model which is commonly used in cybersecurity. So whenever you will design a network architecture drawing or any architecture drawing related to cybersecurity, so some customers will say you to provide it in a Purdue model format, and then you need to show all the levels what we are seeing on the screen on the right side. This type of levels, we need to segregate our instrumentation, our control servers, and everything in this format. So basically, a Purdue model for control hierarchy is common and well understood model in manufacturing industry that segments devices and equipment into hierarchical functions. So we can see like it is going from level 0 to level 5. So there are also intermediate levels. Sometimes you will see it's 3.5, it's 3.75. So it's a quite flexible nowadays. OEMs and service providers and system integrators, they are also tweaking these models, but this was the initial, which was from level 0 to 5. So level 0, which consists of a wide variety of sensors, actuators, devices involved in the basic manufacturing process. Sometimes the safety critical instrumentations, or SIS, that is also kept in this model, but what Cisco has done, Cisco has kept this in a completely separate zone, we can say, and they have started from 0 to 5. So that's what I said you, like multiple OEM providers or system integrators, they depict the Purdue model in a little bit in a different variant or different flavors, we can say, but almost concept will be similar or same in most of the cases. So level 0 is the basic level in the Purdue model, which consists of all the field instrumentation. Here all the communications are happening in either 4 to 20 milliamps or some proprietary protocols. It could be Modbus, DNP, or IC, or field bus. So level 0 is the basic level where it is really close to the process. All the instrumentations and measuring things will be close to the process. And then we have the level 1 basic control, where consist of basic controllers that control and manipulate the manufacturing process. So we are talking about the controllers, IO cards at this level, so which is the key function to interface with level 0 devices. So this basic control will be directly connected to the process. So it's like cables are coming from this level 0 and it is getting terminated at the IO level. Or if these two are the Wi-Fi devices, then they are communicating through the Wi-Fi protocol. So might be in DCS or in PLC, these are the cable communications from DIDO, AIAO. All those cables are connected to the basic control. And this is what we are seeing. These are IOs, linking devices, breezes. Then moving ahead, one level is level 2. So this is area control, it is said. So area supervisory control we can see in the level 2, and level 2 represents the system and functions associated with the runtime supervision and operation of an area of a production family. So here the solutions like HMI will be there, or workstation will be there, or local control panel will be there. So from where you can see you can do a runtime operation or runtime supervision of your process. Then further moving ahead, it is site manufacturing operation and controls, and this is level 3, or this is the highest level of industrial automation and control system. The systems and applications that exist at this level manage site-wide industrial automation and control functions. So basically in this level, the control in this level, the workstations will be there, HMIs will be there, operator workstation, engineering workstation will be there, so that any command or any logic will be built and downloaded from there. So this is a complete, we can say, control room or engineering room of a plant. So all the applications, like whether it is a tri-station, or it is a Foxborough DCS, or Emerson Delta DCS, or Honeywell DCS, or Yokogawa DCS, Siemens DCS, all those DCS solutions, software solutions will reside here. Even sometimes patch management server reside here. Even active, if you have Active Directory control for other for all your servers, that will reside here. Backup solutions will reside here. So all types of management as well as the solutions which is directly or indirectly associated with the control system, that will reside in this zone. So this is the level 3. Then we have level 4 also. So site business planning and logistics. Level 4 is where the functions and systems that need standard access to service provided by the enterprise network reside here. So systems like SAP, ERP, or power planning, or any recipe planning. In some of the manufacturing industries, what we do, we create some recipes and then we download into our engineering workstation, or directly to the controller. Even sometimes those types of systems will reside in level 4, which decides the business planning. Like if we want to schedule our load, like at what time how much load should go, and if that is fully automated and integrated to your control system, to your DCS, then there will be communication between level 4 to your even level 2 or level 1. So this type of solution which decides the outcome of the day or outcome of the complete month. So planning, scheduling, these type of applications will reside in this level. Also, if you have some inventory management, and there is or defect planning and management, like SAP systems, where you maintain all those defects or permits raised by the operators and the maintenance person, and those type of process, if you have there, these type of applications will reside in this level. Then and then in level 5, it is enterprise network, where centralized IT systems and functions will exist. So mail servers, mail to outside, or PI systems, enterprise resource management, business to business, business to customer services typically reside on this level. So company websites are hosted on this level, and all sorts of other IT systems, IT support, IT technical supports will remain. Sometimes BI systems, ERP systems will reside on this zone. Sometimes SAP system resides in this zone. And in level 4, we will have like machine monitoring systems, where
all those performance of the machine data are analyzed. Or in level 4, sometimes we keep solutions like vibration monitoring systems or efficiency management systems. And in enterprise network we keep like SAP or scheduling thing. So these we need to see by the case by case and business by business scenarios, and how it looks like, where it will be more convenient to keep things. So earlier whatever architectures were designed, that was purely based on the convenience and ease of access. But now the requirements are changing. We need to design our solutions based on the cybersecurity needs. We need to think of this based on the cybersecurity aspects of the organization. We need to see what is the risk of that organization, and then we need to design our architecture so that it should be cyber secure, and also it should be convenient to use to at least the set of the population or set of the intended audience only. Like if operator is destined to work on the operator workstation, so it should not be convenient for IT people to access this system. It should be only convenient to the operator or the engineer to access those systems. That is what kept in the mind while we design our solutions for with aspect of the cybersecurity. So that's all about the Purdue model. Let's move. We'll use this Purdue model many times in our course of this chapters. So keep in mind like about this levels, level 0 to 5, what is all about, and then we can move ahead. Thank you. And welcome to this chapter. In this chapter, we'll discuss about the difference between OT and IT. So this is a very common debate, like where people can work, whether the IT people can work in OT and the OT people work in IT. So it's not like it's not about the people. So here it's about the technology and the requirements of the industry. So in OT, if you have heard about the CIA triad, so CIA stands for confidentiality, integrity, and availability of the system. So in OT, availability is the utmost important. So here triad is called AIC. So it's first thing will be availability, then integrity, then confidentiality. But in IT, it is CIA. So confidentiality is prioritized more in IT, and availability is prioritized more in OT. So this is the basic difference between OT and IT. And also downtime and all those things, and health and safety impact is there in OT. So if there is very less chance of error in OT industries. So if there will be error, it can directly impact the health and safety of the individuals. It can turn into a disaster. So these things are making OT a little bit different. So let us see what are the basic differences between OT and IT systems. So now let's go one by one. So first is the performance requirement. So in performance requirement in IT, most of the processes are non-real time or near to real time, we can say. And similarly in OT, all these processes are real time. So what does it mean by real time? Real time, it means in OT that the data flows with the product. So this is one good anecdote what I can say. So if it gives the exact same time, if there is a signal command is going on, it will directly act on the product, which will be at the same time at the same location. So that is called real time. Response in IT is should be consistent. Like if someone is logging into banking system or using something, he should get in return every time same thing. But in OT, it is time critical. So response, it could be a different at a different time, depending on the what business logic it is running and what the state of the system. High throughput is demanded like in IT due to the more data volume, or we always need a 10 Gbps link or 100 Gbps link or 1 Gbps link, but this is not required in OT. So in OT, 100 Mbps network is also okay for running commands, because this barely they consume 4 to 5 Mbps maximum throughput in a 24-hour daytime. So here the commands and data volume is pretty low unless the backups and all those things are running on the system. Otherwise the simple command and those things, they consume very less bandwidth. In IT, a jitter delay might be acceptable, but in OT a delay or jitter cannot be acceptable, because if jitter happens, so let us suppose a digital input is there and it jittered twice or thrice, and these systems are quite sensitive. They even read the data in the milliseconds, and what will happen, the system will consider that I have received 5 commands or I have received 6 commands due to that jittering. And if some delay is there, it might be the exact product chopping or something need to act at a some time, valve should be closed, yeah, at that particular point of time. It may will have the production losses and other responses as well. Emergency interaction is less critical, but in OT, response to human and other emergency interaction is critical. In IT, tightly restricted access control can be implemented to degree necessary for the security. So because confidentiality is of utmost importance in IT, but in OT, access to OT should be strictly controlled but should not hamper or interfere with the HMI or human machine interaction. So if operator needs to access some system, we cannot make the access control so tight that even we will face difficulties in accessing the system, and which can eventually lead to the delays in the operation. So that is what, like, in performance requirement we discussed about the differences between IT and OT, and now I think hope it is clear for the performance as per the performance requirement. So let's move next to the availability requirements. Let's see. So responses such as rebooting are acceptable. So you have often seen, like, if you work on a system and suddenly your laptop gets rebooted, and those are the IT laptops. So that is one a pretty basic example, like responses such as rebooting are acceptable. We need to, and there are some mandatory compliances are also set on this laptop that we need to reboot it, otherwise it will reboot itself after some expiration of some time. Availability deficiencies can often be tolerated depending on the system's operational requirements. So availability deficiencies can be tolerated. Coming to the OT side, responses such as rebooting may not be acceptable, because if let us suppose you are sitting on the operator desk and suddenly your operator console gets rebooted off, so it will be complete loss of sight of the plant while sitting on that, and we cannot do that. So similarly, if I have analogy, it's like rebooting of a plane's dashboard while you are flying it. So that is not acceptable at all. That's why availability is quite important here. Availability requirements may necessitate redundant systems. So to maintain this availability, we need to create a redundant systems, like in loss of the one systems we can switch to the other systems as well. Outages must be planned and scheduled days, weeks in advance. So we need to plan when we can do such type of planned shutdown of our servers, workstations, and other control systems. So that is the maintenance period. We need to find out when the shutdown is coming, when there is a process shutdown, and in that case we can reboot or we can plan our service and maintenance of that particular control system. High availability requires exhaustive pre-deployment testing. So even if we are implementing high availability, we need to ensure this by putting intensive test of those things, so whether it is switching correctly or not. So this was about the performance requirement and availability requirement. Let's move to the other topics. Continuing with the same comparison what we were doing earlier. So in this we'll see first the risk management requirements. So first is manage data, and in OT basically our focus is to control physical world, and in IT it's a major focus to manage the data. Data confidentiality and integrity is paramount, human safety is paramount, followed by protection of the process. Fault tolerance is less important. Momentary downtime is not a major risk, because recently we saw that Google was down, Facebook was down, even some Twitter was also down, Google Pay was down for some minutes, but that didn't had any health and safety impact.
So fault tolerance is essential. Even momentary downtime may not be acceptable. Major risk impact is delay of business operation. Major risk impacts are regulatory non-compliance, environmental impacts, loss of life, equipment, or production. So this is the basic difference in terms of the risk what we can see between IT and OT. Moving ahead, the system operations. So systems are designed for use with typical operating systems. Upgrades are straightforward with the availability of automated deployments. Systems often in OTO, systems often use differing and possibly proprietary operating systems, sometimes without security capabilities built in. So there are lots of proprietary systems. You'll find in local control panels, they are proprietary software, and even they do not have capability to install antivirus or anti-malware or any other type of solutions, because they are not Windows based or Linux based. Could be proprietary, something totally different from the normal operating systems. Software changes must be carefully made, usually by software vendors, because of the specialized control algorithms and perhaps modified hardware and software involved. So we cannot push anytime the software updates. We need to find out the shutdown window and we need to plan it, the shutdown of the system. Then only we can upgrade or update the softwares or implement the patches. But in IT, we see just the less pressure or less requirements, and we can go straight forward for the deployment of the patches and other stuffs. So this was about the risk management requirement and system operation. Let's move to the other some parameters where we can differentiate between OT and IT. So moving ahead, now we'll see how ITs are different for these three sets. There is a resource constraints, next is the communications, and next is change management. So resource constraints for IT systems are specified with enough resources to support the addition of third-party applications such as security solutions. So whenever we size these systems, these are designed with enough resources in terms of the hard disk, RAM, CPU. In terms of OT, systems are designed to support the intended industrial process and may not have enough memory or compute resources to support the addition of security capabilities. So OT resources, if you see any PLC or any HMI or workstation, it will have a limited RAM. It will not have infinite RAM, or you'll find barely 16 GB, 32 GB, or on the servers nowadays we are offering 64 GBs also and 128 GBs also. But if you see earlier, like go back to the 5 year or 8 year or even 10 years, you'll find all those systems have 2 to 4 GB RAMs, maximum 8 GB RAMs, and also hard disks are also restricted. And nowadays IT systems, they can quickly upgrade from their hard disk to SDD, and they can put a very high amount of RAM. They can even replace the servers, but replacement and all these things are very cumbersome in the OT, because due to the downtime required for the plant, and we cannot plan every update and upgrade very quickly. So systems, whatever was designed earlier, or even now, it is getting designed to support the intended digital process. So if all the applications whatever we are loading on that machine, if those are getting run, and even we have like 60 or 50 to 60% loading on the machine, and it's still spare 40% is there, then that's okay, we go ahead with that. But that is getting a bottleneck. If we start applying the cybersecurity applications on the same system, those need more resources, and that can cause a resource crunch as well. Moving ahead, communications. So standard communication protocols, basically in IT you will never find something other than TCP IP or proper communication protocol as a proper communication protocol. Primarily wide networks with some localized wireless capabilities also. So in IT we use maybe wireless capabilities for office wireless, as well as to transmit data from one place to another. Next, we oftenly use internet quite on a large scale than typical IT networking practice. We use
in IT. In OT, many proprietary and standard communication protocols are there. So I can list, because I am from OT background, so I can list you protocols like starting from Ether IP is there, then Modbus is there, then Profibus, Profinet. We have OPC protocols. We have 61850, 60870 protocols, DNP protocols. There are several serial communication protocols. There are some based on the Ethernet protocols are also available. So the datagram, the packet, the composition of the traffic is totally different from one protocol to another protocol. It's not similar. So if you see the datagram of that protocol, of any two protocols of the OT communication, you'll find a different data packet and different type of data and different way of communicating, different way of carrying the payload from one point to another point. So those all depends on the proprietary OEMs, like what Siemens follows, what Yokogawa follows, what Rockwell follows. So these types of proprietary protocols you will find in a plant, multiple types of protocol you will find in plant scenario. Then we have several types of communication media also used, including dedicated wire and wireless radio set. Even if there is a cable communication, not all are the RJ45 connections. It could be RS232 connection, two-wire communications. It could be a four-wire communication. So if a RTD is connected, it could be two-wire, three-wire, four-wire communication from field to IO card. Then if it is a network communication, Profibus works on the two-wire or three-wire communication. Then if it is a Profinet, then it looks like a Ethernet cable, but the protocol is totally different. Then Modbus also, it could be on a two-wire communication, or if Modbus TCP is there, then it works on a Ethernet type of cable we can use. But eventually that needs a converter in between, and we can convert those Ethernet from the Ethernet devices, from Modbus devices to converter, which converts that Modbus to Modbus TCP. Then we can add into the switch, and then we can read it through our softwares. Complex networks that sometimes require the expertise of control engineers. So networks are quite complex. You'll find a star topology somewhere in the plant. You will also find a ring topology in some places. We can find multiple mesh topology. So let us suppose take example of the Foxborough DCS. So they have the mesh network at the lower level, where the field level and just L1 I can say. So at that level there is a mesh topology for high availability. Then if we go above, there is a star topology. So multi topologies also changes as per the requirement of the availability and redundancy. Then moving to the next topic is the change management. So software changes are applied in a timely fashion in the presence of good security policy and procedures. So software changes are applied in a timely fashion. So there is a regularity here that we need to apply the software changes whenever it is available. It could be weekly, it could be monthly, but it is quite more often as compared to the OT industry. The procedures are often automated, so there is no need to manual intervention. So laptops now, if you see our laptops, it gets quick update from the servers, it gets automatically updated, and then it automatically starts as well. But if we go to OT, so software changes must be thoroughly tested for prior to implement. So in IT also it is there that we need to test it prior to implementation, but sometimes we directly get KBs from Microsoft and we directly implement it on system. So that is another thing, but software changes must be thoroughly tested and deployed incrementally throughout the system to ensure that integrity of the OT system is maintained. So we cannot just if some vulnerability is found and we get a patch, we can go for implementation quickly. No, we need to just test it, whether the prior to implementation and after the implementation, whether the behavior of the system is same. It should be tested in a lab and must be released by the OEM. Then only the plant owners or the asset owners, they can vouch on that and they can implement it on their own system. So OT outages often must be planned and scheduled. So we already talked this topic more again and again and multiple times. So any type of shutdown or maintenance activity, we need to plan it and we need to execute it in the planned duration only. So OT may uses operating systems that are no longer supported. Also, it is also possible that because these systems are designed 15 years back also, so some systems you will find is still running on Windows XP or Windows 7 or Windows 8, Windows 10. So might be might be those systems are not supported by the Microsoft, or if there is some application softwares also by the OEMs and they are end of life and they are not supported by even some switches from Cisco, Hutchman or Moksha is there and they are end of life and not more supported by the OEMs, but still they are in use in the plants. So basically, if something is already end of life, we cannot implement a patch on those systems because no longer the patch are being released by the OEMs. So I think with these three sessions on the same topic, we understood what is the basic difference between IT and OT. And if someone asks you, you have a plethora of terms, you have a good comparison between the OT and IT systems, and you can explain it in a very, very professional way. And I think you learned what is the basic difference between OT and IT. So let's move to the next topic. Till then, thank you. Bye. Hello everyone and welcome back to this module, and in this module we will learn about the cyber attacks. So might be some of you are aware of the term, but a cyber attack is an assault launched by cyber criminals using one or more computers against a single or multiple computer or network. So this is the basic definition of cyber attack. A cyber attack can maliciously disable computers, steal data, or use a breached computer as a launch point for other attacks. So this is also a part of cyber attack. Cyber criminals use a variety of methods to launch a cyber attack, including malware, phishing, ransomware, denial of service, among other methods. So this is the definition of cyber attack. So any type of usage of the infrastructure which is inside the plant or inside the organization, and that is being used for their personal concern, personal advantage, without the authorized, or we can say unauthorized, access of those critical systems or any system which has some information, which has some data, which has some control of the systems, that is a type of cyber attack. So in our case, basically DCS, PLC or SCADA or building automation system or IoT network. So anyone if accesses those things to with some different motive to destroy or to make an impact on the organization or to make financial loss or to make health and safety impact, then that is a cyber attack. So cyber attack scale can be a very minute to big ones also. So we have some of the cyber attacks happened in history, so we'll discuss some of them so that you will get understanding of the cyber attacks, like how it looks and what happened actually in a cyber attack. So if someone asks you like what is a cyber attack, you can give some of the examples which already had happened in past. So let's go for the first. This is Worcester air traffic communication. So in March 1997, a teenager in Worcester, Massachusetts, disabled part of public switch telephone network using a dial-up modem connected to the system. So he accessed that network with an already connected dial-up modem. This knocked out phone service at the control tower, airport security, the airport fire department, the weather service, couriers that use Air Force. So once he disabled, so all these services got knocked off because those all were connected with this network. The tower's main radio transmitter and the another transmitter that activates runway lights were shut down, as well as printer that controller uses to monitor flight progress. Everything was shut down. So the impact of this attack was like the attack was knocked out phone service to 600 homes and business in a nearby town of Rutland. So you can see like just a teenager with a basic knowledge, and he did such a big impact. So this happened in really very old time. So in 1997, this was the first type of attack happened with such a quant that knocked almost phone service of 600 homes. Then similar to that in 2000 in Australia, there was an attack happened. So we can say this is a script kiddie or enthusiast who did this hacking, but this Maruchi Shire sewage spill, it is a act of a disgruntled employee or disgruntled outsider employee, we can say. So what happened in this, that in the spring of 2000, a former employee of an Australia organization that develops manufacturing software applied for a job with local government but was rejected. So that guy, his name was Bowden, and what he did, like he was working at a software manufacturing company which provides the software to the local government, which that local government controls the water and sewage treatment. But however, his application was rejected by that local government, so he became disgruntled. And then what he did, over a 2 month of period, the disgruntled employee, rejected employee, reportedly used a radio transmitter as many as 46 times to remotely break into the controls of sewage treatment system. And once he got access to those systems, because he had already the knowledge of this manufacturing software, so he was well known about how the system operates. So he altered electronic data for particular sewage pumping stations and caused malfunctions in their operations. So what was the impact? Impact was very huge. So impact was around release of 264,000 gallons of raw sewage into nearby rivers and parks. So this had a great impact on the environment. Many marine species died, and there was a like foul smell, and the complete area was quite polluted, and it was unlivable for some time. So this was a very huge impact, and this was just done by a single employee. Next, to moving in the progression, like in July 2010, there was a Iranian centrifuge Stuxnet attack. So I think Stuxnet has been used in almost all the cybersecurity trainings. So this is a prominent attack what happened in history. So it was a Microsoft Windows computer worm discovered in July 2010 that specifically targeted industrial software and equipment. The worm initially spread indiscriminately but included a highly specialized malware payload that were designed to only one particular SCADA system that were configured to control and monitor specific internet processes. So in this attack also, the impact was very huge. Many 10,000, almost around 10,000 mechanical centrifuges were damaged. So the attacker tricked the operators with the false RPM in the control room, and in the field the RPM was way high and way low. It was changing so that mechanically stressed those centrifuges and they were damaged. So this was done using a laptop. So there was no any internet connection to this site, but this was a nuclear facility, so there was no any internet connection directly, but this was done by also bypassing the physical intrusions, physical barriers what we implement in the plant. So this was a major attack. After this attack, the world started paying attention to cybersecurity of the ICS. Then again in 12 and 14, two major attacks happened. So in 2014, it was a German steel mill attack. So what the hacker did here, hacker manipulated and disrupted the control systems to such a degree that a blast furnace could not be properly shut down, result in massive though unspecified damage. So impact of this attack was not published publicly, so or it is not available readily. That's why I didn't include it here. But in this attack also, what the hacker did, like they did not let the boiler shut down properly, and it will have the results. So like we studied earlier, that safety instrumentation systems, they guarantee the safe shutdown of the plant if something happens. So they manipulated the control system to evade that logic and to malfunction that logic only. So this is the one attack. Then Samoon is a attack which happened in 2012, and Saudi Aramco experienced a malware attack that targeted their refineries and overrode the attack systems, master boot records, partition table, and other data files. This caused the systems to become unusable. So this was a direct attack on the operating system of the plant and directly on the master boot records, partition table, data files. So at the kernel level and at the boot level, this attack happened, and what was the result? That systems will become unusable, and it had the production impact as well. So these are some of the attacks what we discussed now. I think there are two more important attacks which happened recently. So one was like New York Dam attack. It happened in 2013. So an Iranian computer security company obtained remote access to a computer which controlled the SCADA system of Bauman Dam located in New York. So Iranian computer security from Iran, they got the access of this SCADA system which was controlling the Bauman Dam located in New York. The adversary was able to view water levels, temperature, and status of sluice gate. The sluice gate control was disconnected for maintenance at the time of adversarial remote access, so dam could not be controlled. So this was a mere coincidence that gate was in maintenance and it was disconnected, and so no command was taken and given. So unless if command was also given, that was in maintenance, so it was isolated from the control system. So no major impact happened in this, but though this was a hack which happened recently in December 23, 2015. Also there was a Ukrainian power grid, it is also known as Black Energy 3 attack. So Ukrainian power companies experienced a cyber attack causing power outages which impacted over 225,000 customers in the Ukraine. So this was one of the first type of attack on the power companies. So over 50 regional substations experienced malicious remote operation of their breakers. So breakers started operating. Kill disk malware were used to erase files on the target systems also. So there was one malware which started erasing the files on the target system, including at least one Windows based HMI. The actors also corrupted the firmware of serial to Ethernet devices at substations. This was the first known cyber attack on the power grid. So this had a very big impact in the Ukraine. Like we can see the official figures of 225,000 customers got impact, and many like revamping of those systems, that impact is also there. Then opportunity cost is also the impact. If we add all those things, the cost will go in millions surely. Then again in 2016 there was one power grid attack happened, and that was the Indestroyer we say. So in December 17 2016, a cyber attack occurred at substation outside Kiev. The impact was an outage for customer of one substation for approximately 1 hour. So this attack was only 1 hour we can say, and it was a minor one. This attack is first known malware especially designed to attack power grid. And very lately this Colonial Pipeline attack happened, and that was in May 2021. So this over the 5,500 miles of pipeline transporting more than 100 million gallons per day of the refined product to east coast of the US shut down operations because of the ransomware attack. So this was the new what happened in May, like almost 5,500 miles of pipeline which carries almost 100 million gallons per day of refined product to east coast of US shut down operations because of ransomware attack. So this was the ransomware attack. Colonial Pipeline was victim of ransomware cyber attack which encrypted their systems, IT systems, by exploiting a legacy VPN profile. So there was a VPN profile, and Colonial Pipeline also decided to pay the ransom to cyber criminal group DarkSide in order to have all possible tools, including the decryption tools, available to bring pipeline back to online. The US government was able to recover some of the ransom payment, but not fully. So this attack, like the adversaries just they got the VPN details and they accessed the system, and then they pushed the ransom into the system. So basically these are the few. There are lots of cyber attacks happened in the past, but these are some few of the cyber attacks what we studied here, and this gave you a good idea like what could be the impact of a cyber attack on a power plant or a thermal plant or on a oil and gas industry or on a food processing industry. So these are the multiple examples. There are lots of examples. Lots of cyber attacks are keep on happening on critical infrastructure on daily basis. Like there was sometimes it is disclosure of information, sometimes it is stealing of data, sometimes it's a manipulation of the control variables, or taking control of the plant even from outside. So these types of attacks gave rise to the cybersecurity. So what we cybersecurity professionals do, we study all these attacks and we try to create a defensive solution which can prevent such types of attack which already happened. So or any zero-day attacks, like if something has not happened in the history, but it will come in the future. So we design our solutions to safeguard our critical infrastructure assets from these type of cyber attack. So this is all about the cyber attacks. We studied about many cyber attacks, what happened in the history, and then from this we understood like what could a cyber attack look like. So let's conclude this chapter and let's move to the next chapter. Thank you. Hello everyone and welcome to this chapter. In this chapter we will study about what is cybersecurity, basically what is ICS cybersecurity. So if we go for the definition, cybersecurity is the practice of protecting systems, networks and programs from digital attacks. These cyber attacks are usually aimed at assessing, changing or destroying sensitive information, extorting money from users or interrupting normal business and process. So in upcoming chapters, we will study about the cyber attacks also. So in each of these cyber attack, you will see that the motive of the hacker or the attacker is to interrupt the normal business processes or to extort money or to destroy the sensitive information, or it could be war type of situation like nation states are acting to attack the critical infrastructures of other countries and they want to interrupt the normal process. Simple. So whatever and whoever is doing this, we need to create our solutions, we need to defend our solutions, we need to protect our networks, critical infrastructures from these type of attack. So whatever we do technically and administratively to defend our systems, that comes under cybersecurity. To understand cybersecurity, we need to see a cyber attack also. So what is the anatomy of a cyber attack? So before, if we want to decide defense in depth protection of an organization for an ISIS environment, it is important to understand the methods by the malicious actors to successfully attack these systems. So many of these techniques used by the threat agents are same as those used by security professionals to test network and system for vulnerability. So whatever we do for testing, they do in the production environment for the attacks, and to determine which defense in depth countermeasures to put in place. So it is a constant cat and mouse game, like Jack and Jerry we can say. And the challenge is to ensure that the information and systems available to infiltration are constantly monitored and updated to protect against ever emerging threats. So that is our aim as a cybersecurity professional. We always aim for protection, and as a cyber hacker, their aim is to always intrude those systems. So basically a cyber attack starts with like three processes. One is discovery, another is attack, third is intrusion. So basically what happens in the discovery, so characterize systems, find the weakness and vulnerabilities. Then in attack, it is exploit vulnerable people, process and components. And data exploited and intrusion, data exfiltration, denial of service, command and control operation. So a cyber attack generally follows a process allowing the attacker to perform reconnaissance. Reconnaissance is discovery by using some tools. So if you open Kali Linux, you will find multiple tools like Nmap, Burp Suite and all those things of the targeted business. Then develops and executes the attack. Then he develops and executes the attacks. So in discovery phase, a threat agent performs reconnaissance by probing the network parameter. So they will reach the network parameter to characterize the system. They will determine if there is a firewall or not, what types of web or other internet facing servers are used, and whether their open communication ports are available or not. So these type of activities are done in discovery phase. Then develops and executes the attack, and finally uses the attacker's command and control presence to extract data or achieve the attacker's goal on the system. So their motive is to first identify what is there, and then they will determine the weakness and the vulnerability. When the attacker has determined potential intrusion vectors, they determine that the weakness and vulnerabilities are inherent in the targeted system. So they can get the weakness of the systems from internet also, like if they know the serial number and device number or make and model or the operating system version, they will find a lot of weakness vulnerabilities already published out there. Then for attack method, they can use multiple things like weak authentication, network scanning, removable media, brute force intrusion, abuse of access authority, spear phishing. So those types, they can send a mail to a operator who is sitting in the plant and with a malware attached to it. So once malware drops into that system, it can proliferate or it can migrate to other systems also. So there are several attacks we'll discuss also, like black energy. So it's a similar type of attack where spear phishing mail was used. Unauthorized access attacks can also be done. Then database or SQL injection attacks can be done. OPC DCOM attacks are also done. So there was one campaign called Operation Dragonfly that used OPC classic protocol exploitation. Social engineering attacks can happen. So people will be attacked who are working in that plant. So to gain the knowledge of that plant. So once that attack thing is intruded, initial access is done, they have a good foothold in the plant premises or plant network, then they will start data exfiltration or denial of service or command and control operation, take command of the plant, give command to devices, change the feedback, change the alarm. So this is what we need to see what type of intrusion, what type of attack, what type of discovery technologies are being used by attacker, and we need to define our terms. We need to see what type of technologies we can implement here to safeguard all these things. So that is all about cybersecurity. Let's move ahead. Thank you.
So these are some major components what we need to secure in a industrial environment. So basically this is split into two parts. One is network security, other is endpoint security. So network security is a subgroup of networking. So when we do networking, we need to take care of network security as well. It involves securing the connected network infrastructure from the core to edge of the network perimeter. So if we have a network switch in the level 0 or level 1 and we have network switch at level 4 and level 5, we need to ensure the cyber security of all these switches or all these routers, firewalls, whatever is there in between. Typically managed by a network administrator. So role is assigned to network admin. Network security involves implementing a security policy. So organization must have a security policy and deploying network software and hardware. Two, what is the motive to do that? The motive is to protect the network, its infrastructure and its all traffic from external cyber attacks. To protect all the OT assets and resources available via the network from unauthorized access. So if you have a network, it should be protected that it cannot be accessed from outside in an unauthorized way. So all the accesses to your network, it should be only through the proper access control, through the proper authorization process only. That it should not have the default username password that anyone can just Google it on the internet and they can type it admin or admin password and they can enter into any of the network switches. So we need to take care of all those things. Then ensure authorized users have adequate access to these network OTSs and resources to effectively perform work. So yeah, in motive of protecting assets, we should not overprotect our assets that even the authorized users do not have the access of those things. So what will happen? It will impact your availability, or it may impact at the time of the need when there is an emergency and he will not have the details or he will not have the access to access some of the switches or the firewalls or any other network devices. So we need to find a balance between both of these two, between the access given and how much access given and to whom access is given, to make the environment as a secure as well as the environment as a reliable and operational. So major components what comes in network security are firewalls, intrusion prevention systems, network access controls, security, information and event management. These are the four most essential components of network security. So we need to install firewall. So what does firewall does? Firewall provides a segmentation, and it is placed between the two zones, like we studied some zones in our SCADA topic also. So we can place firewalls between two zones so that it can monitor all the traffics whatever is passing from one zone to another zone. Then we have intrusion prevention system. So intrusion prevention system, what it does, like it is placed in series to the any communication. So it will analyze all those packets, and if required it can block those traffics also. So IPS is not recommended to implement in an active mode. So what we can do, we can implement this IPS just in a detection mode, not in an active mode to block any traffic, and we can analyze all those logs on our SIEM server and all those things. Then we have network access control system. So this is basically for the network related authentications. And then we should have SIEM. So SIEM is a security information event management. So what basically SIEM does, it collects all the logs from all the endpoints, all the network devices, all the firewall switches, and then correlates all those logs. Like if there are 5 invalid login attempts on a switch, it will check is there any intrusion, is there any traffic changes also there. So it will correlate all those logs in the same timestamp, and it will try to find a link between the event and will try to create one incident. So this is the purpose of the SIEM, and it cannot be done manually because the volume of the logs are very high. The volumes of the logs generated by the firewalls, IPS, NAC, even switches, firewalls, they are very high. So it's a very cumbersome to do it manually. So we need a SIEM type of solution so that it can be done automated. Then another is our endpoint security. So endpoint security refers to the protection of organization network against the threat that originate from on-premise or remote devices. So what is an endpoint? Endpoint can be any device such as smartphone, tablet, laptop, server, PC or IoT device that serves as the entry point to the assets and applications at an enterprise. So for basic understanding, like we are industrial people, so we understand language from the industry. So for us, industrial endpoints are workstations, HMIs, control panels, local user interface, historian servers, then any other servers. It could be vibration server, it could be OPC server, management servers if we have any patch management server, backup management servers, active directories. So those are the endpoints, proxy servers and all other workstations and server from other level. So whatever is a device from where the user gives a command or to operate or to manage the industrial control system, those are the endpoints. We need to find a proper security measures for these endpoints as well. So what type of solutions we implement? We implement application allow listing for endpoint. We put anti-malware, antivirus. We put some agents also to collect logs. But thing is that whatever we put on this system, whatever we install on this system, we need to take proper OEM approval, proper vendor approval is required, proper testing of these solutions are required. We cannot directly go and install anything on these systems because that will violate the policy and warranty schemes, or might be we do not have the service level agreement like for doing those things with the OEM. So and also it may impact the process control performance as well. So let us suppose if we install antivirus and it was not tested earlier, and if we install, it can consume the RAM and the hard disk of the workstation, and might be your workstation start operating sluggish, might be your workstation start fetching data slowly, and finally let's take a worst case scenario that it stops working. So in that case, what will happen, that there will be unavailability issue, and we know like in ICS we need to always focus on availability first. So we need to first test it in our offline environment, not connected to production systems, and once it is tested, released and stamped by the OEM and it is functional very good, then only we can implement it in the production environment. So this type of solutions we can implement. We can do proper patch management, we can take backup of our system. So all these type of security solutions we can implement. Endpoint detection response, these are latest XDR, EDR, so UEBA. There are many technologies out there, but we need to see like what is our risk and what type of solutions we need to implement
to mitigate those risks as per our risk tolerance capacity. And it varies from organization to organization, type of manufacturing industry to another manufacturing industry. So it might be the risk in oil and gas industry is higher than in a paper mill. It's simple. So we need to do all pros and cons analysis, then only we can go and decide what we need to implement. So risk assessment is the key. So we can always start with the risk assessment, and once this gap analysis or risk assessment is done, based on that feedback only we need to decide and design the cybersecurity architecture and then implement it. So that's all about the components to secure. Now let's move ahead. Thank you. Hello and welcome to this part of the chapter. So in this chapter we will study about defense in depth principles. So what is defense in depth? Defense in depth is a strategy that leverages multiple security measures to protect an organization's assets. In simple words, we need to implement many technical controls to safeguard our system. The thinking is that if one line of defense is compromised, additional layers exist as a backup to ensure that threats are stopped along the way. So we need to put multiple technical controls in a sequential manner or in a holistic manner, so that if any of those boundaries are surpassed, bypassed or trespassed, the next upcoming boundary should defend it. So defense in depth addresses the security vulnerabilities inherent not only with hardware and software but also with the people. So let us suppose if one person, he has got some identity card of the employee, he accesses somehow the main door, but there should be a biometric also that will prevent him to go inside that building as well. So defense in depth addresses the security vulnerabilities inherent not only with the hardware and software but also with the people, as negligence or human error are often the cause of security breach. So basic, what are the components like we can consider? We can put physical controls, like examples include key cards to enter the building or scanners to read fingerprint, as I said. Other could be for the network security controls. So there is software which authenticates employee to enter the network and uses the device or application. Another could be administrative control, which authorizes employees or any other individual once authenticated to access a certain part of applications or the parts of the network. So administrative controls we can implement. We can implement antivirus. This is the tool that stops malicious software from entering the network and spreading. Next is the behavioral analysis. Like nowadays latest algorithms are available or machine learnings are available which can detect the anomalies in the behavior of employees or in applications or in device itself. So by layering and even duplicating security process, the likelihood of breach is minimized, and that is the purpose as well. So let's see some of the examples here. So we can see there is a one network here. Here we can see the controller RTUs, field bus are at a different location. Then it is communicating with the SCADA, with the control system, field device communication. And we can see here modems are there, data DAS systems are the application server, historians are there, database server, HMI computers, engine workstations. So this is a control system LAN here we can see. Then we have some routers which is extending this communication to external business. Now we have some backup control systems. So there is one dedicated path to backup control system. We have remote business peers. So it could be the power grid companies, the other any other utilities who are the stakeholders of this business. So they are also communicating. There is a VPN access to some third-party center also. We have historian once again. Then we have corporate LAN sitting here. So corporate LAN has like IT authentication server, FTP server, web server, email server, DNS, web application server, business workstations for daily business uses. Then corporate PBX systems are there for the communications. And yes, we can see here one firewall which is this corporate network is connected to the internet, but we do not know whether the backup center is also connected to internet, whether remote business is also connected to internet. So we can see this is a bit of flat network. We can see there is a rarely any segmentation or anything is there. So we can say whether antivirus is installed or not on these systems. So whether proper security measures are installed on this architecture or not. So we can say this is a quite open network, flat network, and very easy to intrude by anyone, and due to the lack of the zoning, lack of the implementation of the technical controls. So we need to move from this system to this system. Like this, in this right side, we can see that we have implemented many firewalls out here. So you see there is one wireless DMZ made for this wireless access point, so that all the communications which is going to the wireless, it should go through a firewall. Then we have authentication DMZ. So if it is a authentication server, that is also that traffic is also monitored by this firewall. Then we have FTP DMZ. So if there is any communication happening between authentication server and FTP, that is also monitored. We have web server DMZ. DMZ, as already we discussed in Purdue level, that it is a demilitarized zone which monitors all the traffic whatever is passing through it. And then we have email DMZ, which will check all those communications in and out of the organizations through email. Then DNS DMZ. So for everything, for all the applications, we have created a separate DMZs, and these are feeding. These traffics are monitored. We have a corporate LAN. Then on corporate LAN, we are putting only the business related or corporate related workstations and web application servers. Though this communication is also filtered, we can see this firewall. So what we did from this firewall, we just created multiple. Initially everything was on the corporate LAN, so anyone can access from wireless to see all these things. But now we have created separate VLANs or DMZs. So now each of this communication is being filtered, and we are generating logs. We are monitoring what is happening, who is accessing, what is getting accessed. All these types of communications are now monitored here. Next to this, if we see this level, in this level we can see that initially there was nothing. One router was there, and these three servers were sitting around. So our aim was to check what is happening here. So what we did, we put one firewall here, and through this VPN communication is now terminating on the firewall. Earlier it was terminating on the router, and then now this firewall created multiple DMZs here also. So authentication DMZ, security DMZ. We put one security server here. We put here one web server. Then we put business communication server. We authentication server. So this authentication server now authenticate all the users. Then only they will have access to ICCP, DB, and external business communication server. That is the purpose of the authentication server. So what is authentication server? If you want to know, like, you need to read about the CA root server if you want to see that provides the authentication. Or for the network devices, there is one radius server that provides the authentication of the radius network devices. So second firewall was implemented here. Then we can see two small firewalls are also here. So this was initial path, like all this control system LAN was going to this backup LAN directly. So what we did, we do not know the state of the other side. So this is the untrusted network. What is untrusted network? Whatever is not in our control, that is untrusted network. Whatever is in our control, that is a trusted network. So from this trusted control LAN, if something is going out and inside, so we put a dedicated firewall here. Then also from external business server, it is going to some third party, maybe remote business peers also. So we put a firewall here. So now all these communications, whatever we see, this is inside the plant premises, and whatever communication is going outside, we put a particular firewall in all these places. So, and this is our internal network, so no need to put here any controls, because these all are in our internal premises. And if we put firewall, yes, we can put firewalls, we can put industrial firewalls, but we need to see whether it is impacting our performance of the industrial assets, industrial communications or not. So we need to weigh our terms in terms of the security, in terms of the performance, then only we can put some technical controls in the place. So there are also blue dots we can see everywhere. So what we did, we implemented intrusion detection system also. So one thing what we did, we put in firewalls there. Another thing, we created all these DMZs. So might be we put all the antivirus on all these servers. We installed application allow listing in all these servers. Then now it's a term to put intrusion detection systems also. So intrusion detection systems are the systems which can detect any type of intrusion happening on your network based on the traffic changes, based on the behavior changes. So IDS is already a different topic, so we need to study about IDS as well. So IDS detects any type of deviation from the baseline behavior. So IDS, what it does IDS are of two types. So one is network intrusion detection system, another is host based intrusion detection system. So network based detection systems, what it does, it analyzes the PCAPs, are the network traffic, and then from that it tries to give you vulnerabilities, it will try to give you asset inventory, it will try to give you the rogue systems, whatever is added. So those types of information it will give you. If there is a new system attached, it will give you information of that. You can get a complete network map from the IDS also. So IDS are being offered by like Dragos, Nozomi, Darktrace, Tenable OT. So there are multiple solutions out there which are providing. So now we can see this is much more secured with just two or three technologies we implemented, and we are moving towards the defense in depth principle. Now let's see some more examples. So here we have one example. So here what we can see, that we have categorized the confidentiality, integrity and availability of each level what we have created. So if it is a physical level like 0, their confidentiality and integrity doesn't matter, because all are the voltage communications. So availability is the highest required. Then this is the protection level, and here we have port servers, meter, serial radio, relay, and here we have a availability is highest always required. So low integrity will also work here. In automation, this is the third, where relay switches, common proxies are there. Yeah, at this level we see that we need integrity highest. If something gets changed at this level, that will disturb the process. Availability is a medium required, because due to the redundant systems available in this level. So level the proposed we can see this is the proposed defense in depth model of ICS network, which has multiple levels, and the levels delineated by their functional tasks and focus on their goals. So level 3 and below are machine based, and communications are largely machine to machine with a focus on ensuring continued operation of the ICS. So below this level, what we can see, all these are like M2M. We have written M2M communications are happening below, and level 4 and above are the human to machine, with a focus on providing high level services like data aggregation, data logging. At lower levels of the ICS, availability and integrity remain the goals, while in human interface regions, confidentiality and integrity are becoming more important. So different aspects of the security are considered at each of these layers. In human to machine communication region, means like level 4 and above, confidentiality and integrity are of higher importance. In the machine to machine communication region, level 3 and below, the need for the availability increases, while the integrity requirements remain same. So in the enterprise world, if email or web traffic is delayed by 200 millisecond or 400 millisecond, that doesn't matter, that won't be an issue. But however, in a ICS or a goose network, relay to relay communication, if should be processed in 4 milliseconds only. If it get delayed, then it will derail the process parameters as well. Similarly, it is possible and suggested to allow list communication in machine to machine region of the IS, but a deny list approach is required in human to machine, because we need to keep the communications in these regions in the allow mode, and in this region we can put in deny mode as well, deny all. So major thing is that the strength of defense in depth model, or that allows a specific security focus at each level. So for each level we need to design provide the security level. So like for physical level, we can say analog data collection and direction devices such as relay, sensors, meters, controls, control unit valves are there. So we can focus on the availability is the focus of this level, because the raw data are transferred here, any processing is taken place. For level 1, what we can again we can say that availability is paramount at this level, both for intelligent electronic devices and their processing capabilities, that of the communications, because of their real-time nature. So these all networks are called time-sensitive networks. Now moving ahead is the level 2. So level 2, our focus will be on the integrity should take precedence at this level. So integrity is important to ensure that the system state and events are correctly reported to operators. So that's why integrity is important in level 2. In level 3, we can say that the integrity and confidentiality increase in importance. So level 3 and above interact with the external networks and cannot always be thought of truly private. So this is especially true when higher levels start including general purpose computers. So which are easier to compromise. So if a computer has Windows or Linux, that is easier to compromise, but a proprietary computer, that needs a specific skill to compromise it. So which is easier to compromise and use as pivots to access control system devices. That is about level 3. Now going to level 4, focus will be on both confidentiality and integrity are the critical importance at level 4 because of the prevalence of the general purpose computers like similar, which availability takes a backseat. So we need to it's almost similar. Now moving to level 5, our focus will be integrity and availability of the parameter or paramount. So if for perimeter security also, the good physical perimeter include multiple layers, like we need to put a barrier or fence, then we need to put access control locks, then monitoring with the cameras. So from an electronic perspective, confidentiality and integrity of the communications leaving or entering are also important. VPNs also we can implement if there are communications happening from outside. So we need to monitor people as well as process all traffic from for this network. And similar, what technology we can implement in each of this level, we can see from this diagram also. So similar type of methodology we have taken and we have implemented multiple technologies here. So if we see here, we have Ethernet firewall, we have Ethernet switch, we have serial communications, machine communication, human communications, all are represented in different forms. We input syslog server, we put authentication servers here. So this type of technology as well as segmentation level wise approach we need to follow in defense in depth principles. So that makes a good understanding of defense in depth principle, why it is required and how it is how it can be done. So we need to put a proper approach by putting a layered approach, layered security. So let's read about, understand about this in our upcoming chapters also. So this defense in depth principle is now complete. Hope you understood. Let's meet in next chapter. Thank you. Hello and welcome again. So now we are moving toward the security architecture. So we need to see what are the contemporary control system architecture. So due to the introduction of the IT components in the control system domains, security problems arise, or we can say security attack surface increased. So increasing, what are the basic driving factors for this increase in security lapses or security problems, we can say. So increase in dependency on automation and control system. So if you go back into the history, so relay logics were moved on the pneumatic valves or pneumatic systems. Some relay logics were moved manually, some valves were controlled manually. So but thus we incorporated these IT components in our control system. The ease of operating these devices increased. So hence dependency on automation and control systems also increased. So in security, again we when once we generated so much amount data, we started connecting or sending it to other sites also to increase more ease of access, to fetch more data insights from the collected data. So that gave insecure connectivity to the external networks also. We often started giving our systems remotely to the vendors so that they can troubleshoot, they can see insights of our systems also. Usage of technology with known vulnerabilities. So once we were so much dependent on the technology, even the vulnerabilities were discovered, we were in no position to remove that technology because or stop using that technology because we were so dependent on those technologies. Or might be we can say, like in some plants, if we are still using Windows XP, so that is the dependence. We cannot upgrade Windows XP to 2010 Windows and run the same PLCs, same software and same IO cards on the system, because those systems hardwares are designed to work with the XP system. So we cannot upgrade complete plant in one go. So this is called that we are still using some technologies with known vulnerabilities. No business case for cybersecurity in control systems, where because there is no return on investment, for we cannot see the tangible return on investment. So that's why there is no business case. control system technologies have limited security, and if they do, the vendor supplied security capabilities are generally only enabled if administrator is aware of that capability. But if we do, or if we add some third party securities also, that can void the warranty and support by vendors also. So that need to be tested, released by the OEMs only, then only we can say that these security technologies are well tested and implemented in our system. Now next is the control system communications protocols are absent of security functionality. So if we see RS-232 serial communication, there we cannot implement cyber security on the serial communications. Or if it is a OPC DA, then it's a based on DCOM communications, and that already has too much vulnerability. So some protocols which are designed, they do not have the security. We cannot add some certificates, we cannot add SSH exchange or secure transport layer communications. That is not possible to do with those protocols. Considerable amount of open source information is available regarding control system configuration and operation. So these are some of the weaknesses or areas where we need to pay attention to mitigate the gaps what are existing now. Now let's move to one of the example of the ICS network architecture, what we often see, and this is the one of the recommended architecture we can say. So basically this is called integrated architecture. So it is based on the Purdue level, and it depicts an integrated architecture that includes connection from external sources such as corporate LAN, so peer sites, vendor sites, and internet. The model comes from the International Society of Automation and provides insight into the widely accepted Purdue model of the control. So this architecture, I think if you remember our Purdue model lesson, so similar type of architecture was there also. So this is a much briefed and much detailed. So we can see in this level we have field devices, sensors, we have field devices, sensors, again level 0, then level 1 we have controllers, we have then local HMI. And if someone asks you that where are the switches, so switches are called as conduits, and they are in between. So you can see that in the between these are the switches. So you can keep switches in level 1 or level 2 or wherever near to the networks, whatever is there. Then we can say this as a cell area zone. Then there are another levels like manufacturing control center, processing LAN in level 3. We have systems like database, IO server, historian in this level. Then in DMZ we have patch management server, historian, remote access, then a firewall here, we have firewall here, we have firewall here. So all these firewalls are helping in segmentation as well as monitoring the traffic what is going in and out of that level. Then we have enterprise zone, we have internet DMZ zone, and all are segregated with the firewalls. So we can keep memory of this thing, that what type of servers we can place in each level depending on the business use case, depending on the type of server, and why these levels are created. So basically these levels are created by the need that each of this level have a similar set of cyber security control. So if this is a HMI zone or it is a local HMI LAN, we can put like application allow listing here, we can add IDS here, we can add antivirus here, and that's done. So these three type of controls we can do for everything. If this is a field controller, definitely we cannot install any application. So what we can do cabinet locking, we can do physical access controls. If this is a field level, that definitely we cannot keep all these devices in cabinet. So sometimes we need to put tagging, we need to do asset inventory, asset management, this type of things. If this is enterprise zone, all these are almost IT type of systems. So you can put EDR there, we can put UEBA, so latest technology you can put it there, because they are not totally dependent on the control system, control losses. So even if web server gets down, there won't be a impact on any communication happening between field controller to local HMI. So this is how levels are there. So basically our standard architecture should look like this, and then let's go to understand what are the architectural zones. So we can see here we have zones here. So this is the IoT part, and this is the IT part of the architecture. So in order to create layer defense, one must have clear understanding of how all technology fits together and where all the interconnectivity resides. So dividing common control system architectures into zone can assist organization in creating clear boundaries in order to effectively apply multiple layer of defense. So if you want to apply multiple layer of defense, you need to clearly identify your zones first. So how to achieve network segmentation is vital in creating architectural zones also. So basically we have here 4 zones. We can see enterprise security zone. So what does enterprise security zone? It includes the connectivity to internet, peer locations and backup for remote offsite facilities. So enterprise network connectivity we can see in level 5, it is there, as well as the business networks that include corporate communications, email servers, domain name systems and IT business systems level 4. So all these comes into the enterprise zone. So like we saw in the previous slide, so this 4 and 5, this comes into the enterprise zone. So in 4, what type of servers are the domain controller web servers? So this comes into the enterprise zone. So a wide variety of risk exists in zone because this is connected to internet, and this zone is considered as untrusted because this is connected to the external network as well. Now second is the manufacturing zone. So this zone is level 3, which contains the area of connectivity where a vast majority of monitoring and control takes place. So in level 3, what is there? In level 3, we can see we have production application server, HMI, database, IO server, historian. So we can say that operational support and engineering management devices are located in this zone. Along with data acquisition server, historian. The manufacturing zone is central to the operation of end devices and provides required connectivity to enterprise zone. If some connectivity needs from top to bottom, this zone will provide all those connectivity. The priority of this area is high, so risks are associated is directly connectivity to any external system or network. We cannot connect directly this system to external systems. So we need a DMZ here, which will filter and monitor all the activities what is happening here. Now next area is the cell zone, cell security zone. So cell security zone contains systems used for local or remote area control, level 2 devices such as field located HMIs, PLCs and their controls. So level 1 and basic input output devices such as actuators here in this area, such as actuators and sensors. The priority of these zones is very high, and these are the areas where the control functions affect physical end devices. So basically each of these zones, whatever we study, requires a unique security focus. So peel the onion analysis, we can say. So peel the onion analysis shows that intruder trying to affect a critical infrastructure would most likely to go after the core control domains contained in level 3 and below. So whoever wants to enter your network, they want to access this area. So they need to peel whatever security you have provided here. They need to first peel this layer of the onion, then second layer of the onion, then third layer of the onion. So that way we need to create the multiple layer of the cybersecurity so that it look like an onion. So that is about the zones. DMZ. So let's discuss something about the DMZ. DMZ is sometimes referred as perimeter network. So you can put multiple DMZs also. Whatever is your perimeter exposed area, so there you can put a DMZ. It's a physical and logical subnetwork that acts as intermediary for connected security devices. They avoid exposure to the larger untrusted network. So DMZ, whatever it will allow from here to expose, that will be only exposed. So an external intruder had direct access only to the DMZ, not inside it. So that's about the DMZ. DMZ is a must, like we need to implement it in our architecture. It gives a very well security. So we need to always try to achieve this type of architecture wherever we are designing, whether it is a small architecture, big architecture, we should go for this recommended architecture design, and it will give a good level of security and also visualization to the designer as well as engineers. So this is the recommended architecture, and I think we have enough discussed on security architecture. Let's move to the next topic. Thank you.
Hello and welcome again into this module, and in this module we will discuss about the foundational requirements. So it might be a bit surprised that this term we haven't used earlier, but this is pretty common term what we use in industrial systems and when we deal with the cybersecurity. So basically this term is coming from this IEC 62443. So what is IEC 62443? It is a worldwide de facto standard for security of ICS, and this standard was created by International Society of Automation, and which is also called ISA. Sometimes it is called ISA 99 also. That was the former name of this standard and was taken over by International Electrotechnical Commission, and then we say IEC 62443, who is responsible for further developing it. So basically IEC 62443 assists in the evaluation of existing and potential vulnerabilities within ICS and aids in applying the necessary mitigations. So if we see, the goal of this standard is to reduce the risk of threats and failures within ICS networks. The standard consists of 13 documents. If you want to see about more in details, so it consists 13 documents which are grouped into four groups, that is general, policies, procedures, system and concepts. So we are not going to discuss that in detail. If you are interested, you can see it on YouTube or somewhere else, or I will post another videos on this. But we'll take some of the important things what we can study here. So we'll today study about the foundational requirements. So these are the foundational requirements as per the standard 62443.3 and 4.2. So basically the foundational requirements helps us to design our cybersecurity technical control. So there are 7 foundational requirements. First is identification and authentication control. So we need to implement cybersecurity solutions for identification and authentication. We will discuss about all of these in little bit details in upcoming chapters. So let's go one by one for now. So another is use control. So we will study about the auditings and law controls, what type of use control we can implement. Then about the system integrity, how we can maintain the system integrity. First we will understand what is system integrity. Then data confidentiality, what we can do about the data confidentiality. Restricted data flow, so what other solutions we can put, whether firewall is required, whether segmentation is required. Then timely response to events is also a foundational requirement, like if some event happened, then are we going to do anything? So those steps and those things what we can do, that comes under timely response to events. And finally is the resource availability. So it means like if something happens in our environment, then how we are ensuring the resource availability in our environment. So basically in upcoming chapters we will discuss about these 7 foundational requirements as per IEC 62443, and this will give you a good insight. So let's go to the first one, which is identification and authentication. So as the name states, that this terms is something to do with the identification of a user to some system, against some system, and authentication of user against the identification what he provided or she provided. Or even if it is a software that needs to be identified for accessing some process, or need to authenticate if already the software has username, then it's something what they have. So basically the official definition of access control is reliably identify and authenticate all users. Users could be humans, softwares, processes and devices attempting to access the ICS. So prior to moving ahead, we need to understand basically what is identification, what is authentication, authorization or access. So authentication is the initial process of establishing the identity of user. You need to authenticate yourself. So how would you authenticate yourself that I am the authentic user? So there will be a username associated with that, or there will be some identity revealing. So like we have our own identity. My name is my identity, or my some number, government issues some number, that is my identity. Or if a device has IP address and host name, so that host name is their identity. So that is one thing. And authentication is the initial process of establishing the identity of a user. Then we have authorization. So what is authorization? Authorization adds an extra layer of security
to the authentication process. So it specifies access rights and privileges to resource to determine whether the user should be granted access to data to make a specific transaction. So if some user wants to do something in the network or do something on the device, then he need to be get authorized for that activity, whether the required privileges are available for that user or not. So that comes under the authorization. So authorization, we'll see what are the examples of authorization. We'll study about those things as well. And then we have access. So once a user has completed the authentication and the authorization steps, their identity will be verified. This grants them access to the resource they are attempting to log in. So we'll discuss about these access controls later. We have a detailed slide for that. So let's move and see about understand like let us clear our concepts about the differences in between identification, authentication, and authorization, because these three are three different things. So let us suppose if there is a user, he has some user ID or username or physical access control, so that is his identification. Even for the physical control, if he has some card, so that is his identification. Then ambient access points information password. So if he enters the password, so that is the authentication happening in the backend. And then granting or denying or determining the resources. So if any of these three things is done by the system, it authorizes to access the resources. So basically identification describes a method of ensuring that the subject is an entity it claims to be. So a username or account number or his identity card, that is the mode of identification. Then we have authentication. So authentication can be categorized into multiple groups. They are also called authentication methods as well. It could be something you know, something you have, and something you are, and something you do. So these four things we can add in this. So it is a method of proving the subject's identity. It could be a password, passphrase, PIN. So something you know, that is the password or passphrase. Something you have. Let us suppose you have a access card and it has the password. Also, it has the PKI certification. Then that is letting you enter inside a premises. So that, or you got an OTP from the website. So that is also something you have. And something you are. So let us suppose you have to enter somewhere and you have to use your fingerprint or your retina scan. So that could be the something you are, that cannot be changed. And something you do, like some signature pattern. In mobile also we need to make some patterns, we need to do some signature, we need to do dynamic keystrokes. So that is the you do. So authentication can be done by these four types of methods. So these are authentication methods. Now I think now identification and authentication is clear. So now let's understand what is authorization. So authorization is a method of controlling the access of objects by the subject. So a user cannot delete a particular file after logging into system. So let us suppose you are identified, you are authenticated. Now what privileges you have? Can you delete a file? No. Yes. So that is a privilege. Or we can say that authorization determines the access level of the subject to the object. In other words, authorization determines that the privileges of the user or subject, how it can interact with the object or the system or the resources. So let us suppose here classification of documents or the system comes into role. So whether it is a secret, top secret, restricted, classified, unclassified, confidential, internal. So those tags you have seen on some of the documents or some of the systems: supercritical, critical, monitoring, operator, guest. So all these things are the authorization. So to sum up, what identification, authentication, and authorization is: identification occurs when a user claims an identity, and authentication occurs when a user provides a credential. So once a user is authorized, access level, privilege of the resource is managed through authorization mechanism. So basically now I think we have clarified it enough. Now let's go back to this part. So what are these? These are the types of access control. So first is the attribute based access control. So ABAC is a dynamic context based policy that defines the access based on policy granted to user. So if some attribute of some system is there, so that will defined in the policy and access will be granted to the user. Then we have role based access control, and this is pretty common in ICS. Others are not much common, but rule based access control and role based access control are pretty common. So RBAC creates permission based on the group of users. So let us suppose if I define that these all are engineers, their A, B, C, D users are, these all are engineers, and their roles we can identify. They can modify the logic, they can create the logic, they can download program, they can upload the program to PLC. So those will be the roles that user hold and actions that users takes also. So users are able to perform any action enabled to their role and cannot change the access control level they are assigned. So this type of role-based access control you have seen in DCS, like there is an operator group, there is a maintenance group, there is a network admin group. So multiple type of user groups are there, and their specific and respective privileges are assigned to it. So that is called role-based access control. Now mandatory access control is a place where strict policy on individual users are and data resources and system they want to access. The policies are managed by organization administrator. Users are not able to alter, revoke or set permission. So these are some mandatory access control, where let us suppose you want to shut down a server. So for that there will be only specific user can do that thing by accessing the control room. They will have the card, they will have the permits, the opening the cabinet only, those two people will be required to open the cabinet. So those type of access is called mandatory access control, and it will have a very strict policy. Now next is discretionary access control. So DAC model allows the data owner to decide access control by designing or by assigning access rights to rules that user specify. So when a user is granted access to a system, they can then provide access to other users as they see fit. So this depends on, we can include this type of DAC into a permit system. So when we go for a permit and the user allows us, yes, you can work on this system, you can take, shut down this system. So at that time, if they give you some username and password, that will come under the discretionary access control. Then we have break glass access control. So break glass, as the name says, it is the emergency. So in case of critical emergency, user is given immediate access to the system. So that is called break glass access control. And rule based, as the name says, rule based approach sees a system admin define rules that govern access to corporate resources. So these rules are typically built around conditions such as location or time of day of that user. So if I give permission to the vendor that you can log in between 2:15 to 2:30 p.m. from this IP address, then only you will get access. So that type of rule you can create. And then finally we have physical access control to grant access to physical building and physical devices. So this is all about the identity and authentication. Hope I clarified all these points, and differentiation is the major thing. So let's move to the next topic. Thank you. Hello and welcome again in this chapter. This is about the use control, and this foundational requirement is also coming from 62443. So basically what is use control? It is about the control system shall provide the capability to generate audit records relevant to the security for following category. So we need audit records for all these categories, whatever is mentioned below. So let's go one by one. So first is access control. So let us suppose if someone accesses some switch, or let us suppose operator just logged on into the operating workstation and he started giving commands and he started his routine process. Or let us suppose engineer does a logic modification and he downloaded the program to controller. So these types of access, so for this he did access, he took access of workstation, he took access of the controller, he took access of the network switch. Similarly, operator takes access of operating workstation. So all these accesses, or any software is taking access of some resources, of some database queries happening in the system. So all these accesses, whatever is happening there, this comes under the access control. So we need to retain the logs or the audit records, like yes, this person has done this type of activity somewhere. So we are usually logging all those things. Just we need to keep those things and retain, so that in the time of the need or the forensics, if something happens in the environment at the later stage, we can show it to the authorities that yes, we have the audit log. So this is the first thing, that we need to generate and keep the audit records of the access control. Now second is the requester. So let us suppose if some user wanted to retrieve the backup from the backup server, and due to the credentials mismatch, it got rejected. So this is one type of the error generated, or might be the file is corrupt, it was not correctly, so that there was a errors generated. So this type of errors, whatever errors is happening, so those will also generate a record. We need to keep systems in place that we should ensure that yes, this type of error happened and this request error has been logged in a file. Similarly, moving forward, operating system event. So operating system, we use basically most of the control systems. Workstations are basically hosted on the Windows operating system. It could be Windows XP, Windows 7, Windows 10, Windows 11, or it might be some Linux, Red Hat Linux, or some Debian Linux system based, or some proprietary operating systems, might be some containers inside the proprietary automation or application servers. So we need to ensure that all these operating systems, whatever day-to-day activity is happening on there, it could be user access, it could be a data movement from one place to another movement, it could be delete of some file, addition, creation of some folders, creation of some files. So those type of all activities, it should be logged at a place, whatever is done at the operating system level. So if someone is changing the IP address, or if someone is changing the host name, or someone taking remote of some other system from one place, so all these types of activities we need to create the records, audit records for all these activities at the operating system level. Now moving ahead, control system events. So on operating system, what resides, there is a application software. So if it is a DCS, there will be Foxborough application, or if it is a SIS, there will be a TriStation application, or it is a, like in DCS there are many examples, like it could be Emerson system application, or it could be a Honeywell application that will reside on this operating system. Or if it is a SCADA, there will be some SCADA applications running on it. So now user accesses that SCADA application or that proprietary application to do the logic changes, or do operating changes, or do some configuration changes on that platform. So those all those systems or applications must have capability to generate audit logs for those things. Let us suppose if we log into the Windows, then we need to log into that application also, and if that login failure also happens, we need to log that event, and eventually we need to collect all those events at a single place also. Or if someone initiated a program download and program download failed because due to some reasons, so that is one of the event, we need to catch that event also. So this is the control system events. Moving forward is the backup and restore events. It's a similar, like we know that we store backup at regular interval on a standard repository server. So we need to take backup of the system. We need to do restore in the time of need whenever restore is required. So whether backup has been saved correctly, backup was finished properly or not, or backup related errors. So whatever incidents or steps or sequences happening in the backup, we need to generate logs for that, and we need to store those logs or events in our database as well. So that is related to the backup and restore. And in case if we are restoring something, it might be the case of the emergency, or it might be case of the regular testing process. If restore is successful or restore is failure, we need to keep a log or events for backup and restore events also. Configuration changes. So let us suppose if we are doing some configuration changes at the network level or the endpoint level or the application level, then that should also be stored somewhere. If we have a configuration management system, then everything will go through that. If we have a permit system, then it will go through the permit systems, like we cannot change anything without a proper permit or permit by the operation department. So we need to take care of these configuration changes. Then moving ahead, potential reconnaissance activity. So detection tools need to be installed in the premises, so that if some reconnaissance activity, what is reconnaissance? Like exploring or searching or try to identify something, these all things are called reconnaissance. So basically we some network reconnaissance activity or system identification activity is happening. It could be a physical, it could be a digital. So digital examples are like just doing a nmap scan from the Kali Linux in the network to identify the number of IP addresses, whatever is being used, or the operating system of the devices, the MAC ID of the devices, the open ports. So these types of activities, if performed on a normal running plant, so that is a deviation from normal working procedures. So those activities, if it is happening, we need to put a system in place that can detect these things and create a audit log for that. Now, audit log event. So if there is any audit happening on there, so might be we have some automatic tool for doing the audit of the systems as per some compliance, as per some state or national or some compliance. So those audit log events is also required if it is a vulnerability assessment or vulnerability scanning. So if it is passing, failing, so those type of events we need to keep as well. So these are the major categories where we need to generate the audit logs, audit records is required. Now, how can we do this? This we can do by continuous monitoring. So we can continuously monitor network and device activity in a real time, and alerts or logs events of interest such as network reconnaissance activity, unauthorized access and communications, failed and successful remote login attempts, error and malfunction indicators from field devices, control system events, example like maintenance operations and ICS device configuration changes like program firmware updates. So we need to monitor all these areas, all these areas of interest. So we need to monitor these things. So if something happens in these areas, we need to check whether what's happening out there. Then alerts and logs contain all the details required to analyze and response to the event. So whatever alerts or logs we are generating, that should follow a proper template, proper format. So there is an international standard for logs and events also. So it should contain timestamps. So timestamps should everywhere, like it will be vital information if we want to create a sequence of events. Then source and the target, it should be coming directly from the source and where what was the target information. Then event type, what are the potential causes, impact and the recommendations. So alerts and logs can be filtered and exported for offline analysis for inclusion in audit record. So if you go into Windows Event Viewer, you will find that there are the alerts and logs out there, and we can see, we can find the timestamp, we can see source, target, we can see information. So if you want to see how does the event look like, so if you go to Windows admin, Windows Event Viewer, you will see admin logs are there. These are the warnings, these are the errors, these are the warnings, and you can see that it has a level, it has a date and time stamp, it is a source, it has event ID, task categories also there. If you go for the details, you will find some of the details here written about like the device is not ready, performance data for service is not available. So these type of details are required for the log, whatever we do. So this chapter is about system integrity, and this is the third foundational requirement. So basically, it says that ensure the integrity of the IACS or instrumentation and automation control system to prevent unauthorized manipulation. So here we will talk about how to ensure the integrity of our IACS environment. So providing data security includes protecting the confidentiality, integrity and availability of data at rest and data in transit. So what is data at rest? Whatever data is in rest position, so we can say it is a data at rest. We'll study about that. You can see like if a PLC program code or robot programs or computer aided draft CAD files or computer aided manufacturing files, operating manuals and documentation, electrical diagrams, network diagrams, historical production data. So all these things are called data at rest. Then data in transit, it is information flows from OT security domain to other security domains, and the connections between security domains are monitored. So any data, whatever is flowing in the traffic, that is data in transit. Technologies like data diodes, firewalls, and access control list can be used to restrict the information flow. So these can be monitored by putting these type of devices where they have capability to see this information flow, to restrict the information flow also. So this is what we are saying, that providing data security, including protecting the confidentiality, integrity, and availability of data at rest and data in transit, protecting assets after removal, and preventing data leaks. So this is a complete life cycle. We need to protect data from its initial phase to the end phase of the life cycle of that data. So use of cryptography can support data security, of course. So whenever we will talk about confidentiality or integrity, cryptography will always kick in. So cryptography can support data security. We'll study how it is cryptography and how it can be done. So encryption, digital signatures, hashing, and other cryptographic functions are available to prevent unauthorized access or modification of data. So we'll use encryption of the files, encryption of the communication, then digital signature for authentication, hashing for checking the integrity of the file, and other functions are also available. So let's move to the next. So this is about the encryption. So what is encryption? We'll take one file, we'll add some cipher code and then a ciphertext, then your original message will become a encrypted message. So basically there are two types of encryption. One is symmetric, other is asymmetric. There are more, but we'll discuss the basic these two here, symmetric key and asymmetric key. So what happens, we take one message here, original message, then there is a symmetric key and we apply encryption. It becomes a ciphertext. So you cannot read, this is non-readable. You cannot read and see, it's not understood by humans as well. So then again you need to once you can transfer these files through any communication channel to the sender receiver. Then once receiver receives this file, he will use the same symmetric key to open, decrypt that file, and once it is decrypted, then he can read the original message. So your message during the transit or during the rest, it remains in a ciphertext. It will remain in a such a format that it cannot be read by everyone. It can be only read by those individual or those programs who have this symmetric key. If they do not have this symmetric key, they cannot open and read this file. So this is one type of encryption which uses symmetric key method. Now asymmetric key. What is asymmetric key? It has a two pair of keys. In place of, like in symmetric key, we saw that the same key is with the sender as well as the receiver. But asymmetric key, what happens? We have a message, we encrypt it using the public key, and then it converts into the ciphertext, and then we use a private key to open the decryption file and then decrypt it, and then message can be readable. So what is happening here? These two keys are distinct keys and this is not same key. So only the people or the individual or the program who has this private key, they can read this thing. So there is a two different pairs of keys. So in case of public key is lost, nothing can happen, like only people can encrypt it. But in case of if only private key is lost, then there is a case of thread that anyone can read that, or someone who has this private key, he can read that message once he know that it is coming from this sender and this is the message. But in this case, what happens? Symmetric key was used for encryption and decryption for both things. So in case symmetric key is lost, he can do encryption and decryption of that message. So this is a basic encryption principle. What happens? So moving ahead, these are some recommendations. So critical OT data should be protected while in transit, especially over third-party network segments and other untrusted or vulnerable network paths. So we need to find what are our vulnerable paths or untrusted networks. So whatever is not in our control, like if not in our full control, that is called untrusted. So if the communication is going over cellular communication or wireless communication or internet or WAN, then those communication need to be protected using encryption. first identify which data is critical. Also, we need to put our efforts where there is a requirement and data is critical or data is a confidential one. Then implement cryptographic mechanisms, that is encryption, to prevent unauthorized access or modification of system data and audit records. Like as we understood in previous slide, that if we encrypt our data, it will become unreadable format in both cases, and no one can understand what is in that payload and what is in that data. So it will prevent any unauthorized access or modifications of the system data, or even the logs. If you have stored at some place, if it is encrypted, then no one can alter the logs or the contents of the logs, whatever is stored there. Encryption provides a mechanism for ensuring confidentiality and integrity for data in transit as well as in rest. So encryption, if you encrypt your data, it will provide confidentiality because it is in ciphertext and it cannot reveal anything. So you will no one can read anything. So that will provide confidentiality as well as integrity, that it cannot be changed by anyone. So by implementing those solutions, we will ensure the integrity of ICS to prevent any unauthorized manipulation, and thus we can fulfill the foundational requirement as asked in the as asked by the 62443 requirement. So that's all about the system integrity. Let's move to the next topic. Next is data confidentiality. So in this we'll understand, like it's a similar to integrity, like similar type of solutions we implement as encryption. We heard that in integrity we have to implement encryption, and encryption also provides data confidentiality. So requirement is that to ensure the confidentiality of the information on communication channels and in data repositories to prevent unauthorized disclosure. So we need to put confidentiality measures that it cannot be accessed by, it cannot disclose something. So let us suppose you have a PDF file and it has some report, and you want to keep it at a shared location, but you don't want to make it exposed for everyone. So you can log that file with some username and password. So then whosoever will have the username and credentials, then he can only access and read that information. So in that case, what will happen, that data you can keep it at a shared location, but it will not be exposed to everyone. So that is one of the examples. Other examples, like if you receive your bank statements or your stock holdings, that those files are secured by a username password that is only known to you. So those things are measured to maintain the data confidentiality. So first thing here comes is that the data classification or the file classification. So in most of the companies you'll find the files, folders, programs, all those are classified into like confidential, non-confidential, public, internal. So there are several classifiers out available there for classifying the types of the documents. So let us suppose if it's a patent, it will be a trade secret, it could be a very highly confidential. If it is a financial information, that could be a confidential information. But if it is a flyer or advertisement of the company, that could be a public document. So we need to first classify our document, that whether it is a confidential document or whether it is internal. So after classification, then we can find out those documents or those programs or those areas even, and then we can put a proper cybersecurity control to maintain that thing. So our standard says that to ensure the confidentiality of the information on communication channels as well and in data repository. So it is also talking about the data in transit and data in rest to prevent unauthorized disclosure. Now what some measures we can implement? So first could be like enable users to verify that the sensitive information is communicated using secure encrypted protocol and cipher suites. So if a user who is communicating over the untrusted network, that communication must be secure. So let us suppose if third party is accessing the terminal server in the DMZ of your plant, then that communication must be through a secure channel. That could be, we can use a VPN tunnel with dual factor authentication. So that could be one of the solutions for that. So wherever if there is sensitive information coming through the mail, we can encrypt it using the PKI. So some organization uses that also, that they encrypt email communication also while sending it through the untrusted network, and that is the internet. Users should receive real-time alerts if insecure protocols are used in exchange sensitive information. So let us suppose if the file is classified as confidential and we are sharing it through the without encryption to someone on a inside a plant also or outside a plant also, then in that cases we should put some system which can analyze that what type of data this user is sharing on this network. And in case if that is defying the policies whatever we have said, that we have to send always, like in previously we said that we have to send all the sensitive information using a secure encrypted protocol, but if user is defying this policy, then in that case a real-time alert should be raised and it should be sent to the concerning stakeholders, and then next action or next control we can put in that system. The alerts include information about the source and destination of the devices. So the alert which will be raised for the previous incident, that should contain source and destination, like from which source to what source it has been sent, whether it is uploaded to Google Drive or whether it is sent through mail to someone, or it's just like upload to some box drive or box folder, so that the remediation actions can be taken. Example, if insecure version of SSL can be disabled on the host. So let us suppose if as insecure version of SSL is there on the host device from where this data was exfiltrated or tried to get exfiltrated, then we can disable that host. And this version can be disable that host. Or otherwise what we can do, we can suspend that account, we can lock that account remotely, we can take proper measure, we can withdraw privileges from Active Directory. So this type of actions we can take to prevent this data exfiltration. Otherwise there are many other solutions also. Let's move to deep dive into this topic. So what we can do, so basically we have these 6 methods what we can implement to ensure the data confidentiality. So let's go one by one. So first is the restrict access to data. First we need to restrict the access to data. So access control should always be based on the principle of least privilege. Like not everyone should have the authority to change that file or update that file or edit that file, alter that file or content of that data. So it should have the least privilege, like read only, see only, that type of privilege we need to give, which means that you should only grant access to the data on need to know basis. Any data should not be open to everyone. So if someone is from the financial background, he should not have access to the plant PLC programs, or similar vice versa. So if someone has a engineering access, he should not have the network admin access, or he should not do any changes in the network. If someone is a network administrator, he should not have rights to do anything on the Active Directory. So if operator should not have permit or access to change the program or alter the logic. So this is called restrict access to data, and it should go through the least privilege, which means that you should know only grant access to the data on a need to know basis. Then moving ahead, encrypt your data. So one of the best ways to protect data confidentiality is encryption, because all these encryption protocols or algorithm work on a forward principle. Like let us suppose if it is a sum of 1000, so there are many ways to get a sum of 1000. It could be 500 plus 500 can come to 1000. It could be 999 plus 1 is also 1000. 998 plus 2 is also 1000. So this is like that. So once we encrypt that mathematical calculation cannot be reversed back. It will take ages to reverse it back to find the exact sum or exact code what was prepared, what was constructed while encrypting that data. So it's very tough to decrypt, and nowadays going around 128 byte encryption, 256 8-bit encryption. So that is again very cumbersome, and it will need huge resources and compute power to do the reverse calculation of that encrypted data. So simply put, encryption is a process that uses an algorithm to turn data into unreadable format. So if your data is in unreadable format, it cannot be of use by the adversary. So only authorized people can decrypt the data and read it. So only authorized people, how can they decrypt? Either they will use a symmetric key or they will use a private key to decrypt that data to read it. So this is one of the best way to protect the encryption of the data. So nowadays if you go and buy some NAS drives or SAN drives, so they also have the functionalities for data encryption at rest. So they will maintain the integrity and confidentiality by using the encryption algorithms. Moving ahead, implement a confidentiality policy. So policy, if we are setting up a policy, it is acting as a deterrence. So we should write the policy, and a confidentiality policy includes instruction on the how employees should handle confidential data to ensure its protection. So if something comes into the policy, then employees, it will be a legal bound by to the employee to follow the policies or procedures whatever is written in that policy. So if it is written that confidential data must be sent through an encrypted mail, then everyone has to abide that policy. If someone is not abiding them, then the alerts will be raised, as we discussed earlier, that if something is sensitive data and it is not sent over the encrypted channel, then alerts will be raised and it will be identified and proper remediation measures can be taken. So implementation of confidential policy is another mechanism. Now moving next is the implemented data retention policy. So data retention policy makes it easier for employees to understand that what data they need to store and how long, and also how to safely dispose of data when no longer necessary. So let's take an example. In a plant environment, log generation will be in the amount of the TBs, terabytes. So if we start keeping everything, all the logs, then you will need a very huge storage. It could go to like 1000 terabytes or might be more than that. So we need to make a retention policy. So shall we need a 90 days retention policy, or are we going to store only critical logs on and only for 1 year? So that is the retention policy. Or are we going to keep everything for 5 years or 10 years or 20 years? As per the requirement, if it is a process performance data, if it is a health record data, then we need to keep it for the longer period as per the life cycle of the plant as well as the life cycle of process, whatever is in place. So we need to make a retention policy based on our business requirements as well as our process. So this type of policy we need to create, and then also we need to create a disposable policy of the data, like when to dispose the data. If a task is done, if the usage of that data is done. Let us suppose we use sometimes some training data to train our machine learning algorithm. So once that training is done and process is running in smooth, we can archive that, or we can even dispose of those data also. So one more principle is that in upgrade of technology. So let us suppose earlier we were storing all our data in CD and DVD drives, and now SSD and NAS and SAN, all those drives are in picture. So we need to break and we need to destroy all our data, whatever was written on that CD, DVD or those tape drives. Now we need to move all those data on this latest storage devices, and then we can destroy that data what was stored earlier and obsolete technologies. So that is one thing. Next, moving ahead, is the develop and implement a cybersecurity program. So cybersecurity program provides a comprehensive overview of your company's electronic data and risk it faces. So whatever cybersecurity program you have, it should have a section which deals about the electronic data and risk associated with it, and how to adhere or how to manage those risks related to the data security. Most importantly, it includes all the measures you should take to ensure confidentiality, availability, and integrity of the data, whatever type of the data it is. Then take physical security measures. So this is not last, but it is quite important to ensure physical security. This is the first line of the defense of any industrial control systems. So protecting your data against cyber threats is not enough. You should also safeguard it against physical threats such as theft also. So you should not put your NAS drives or hard disks or the pen drives at such a location and such a situation that it can be stolen from that place. So this can be done by using an office alarm system, locking up paper-based confidential documents, files, installing surveillance cameras, and other solutions also, like entry, exit monitoring. We need to give physical controls, card access, So all those types of control, physical controls also we need to keep, so that we can ensure that all the data whatever we have kept, this is kept in a complete supervision, and it is safe at that place. So that's all about data confidentiality. Hope it clarified you, it make you understand like what is data confidentiality in terms of industrial control system. Let's move to the next chapter. So this topic is about the restricted data flow, and in this topic we will learn about the data flow control technologies. So what is the requirement? Requirement is like segment the control system via zones and conduits to limit the unnecessary data flow. So in Purdue model also we studied about the zones, like how can we segregate our control system architecture into the zones, and then conduits are the just link between the levels. It could be a firewall, it could be a switch or router. So those all communication channels are called conduits. So basically this is the requirement as per the 62443 standard. So if you can see this diagram, we have previously discussed also this architecture. This is not as per Purdue model, but yes, of course we can see it as a zone model, we can say. So what we can do, we can do this restricted data flow to guarantee that no undesired communication or information flow occurs between two zones. So we first aim is to prevent any undesired communication. Then real-time alerts are raised in case violations are detected. So let us suppose we have put a firewall here, and this is zone 2 and zone 3, and there is some illegit or some undesired communication is happening here. In that case, what will happen, this firewall will drop that packet, and the alert will be raised and it will be sent to the log server or the SIEM of the environment. So this is how we can do real-time monitoring, and we can prevent undesired communication between the zones. So earlier, if you remember this figure, it was a flat network and there was no any firewall between the zones. So now once if we implement a firewall here also, if from zone 1 to zone 3, if some communication is being tried which is not supposed to, then in that case this firewall can also raise the alert, and that will be monitored by the system. Or if you have a SOC environment, then SOC analyst can see all those alerts. Then a network device at zone boundaries will provide the capability to prevent general purpose person to person messages from being received from users or systems external to control systems. So this is basically talking about a firewall at the zone boundary. So if it is a zone 1, so this is its boundary, and at boundary there should be a boundary protection device, and it is a firewall. Similarly, you can see between each zones there are firewall here, there are multiple firewalls. So these firewalls are acting as a zone protection devices. Then yes, this zone boundary protection device firewall is not the only device. So we can put unidirectional gateways, we can put data diodes, we can use sometimes router with access control list to prevent some of the communications, but it will not have like antivirus capability or intrusion prevention detection capabilities, or some other capabilities what firewall has. But yes, router with ACL or layer 3 switch with ACL can also serve the purpose, but it's not exactly the firewall. The control system shall support partitioning of data, application and services based on criticality to facilitate implementing a zoning model. So we need to see the criticality, whether which is system or which is more critical. So here we can see like we have PLCs, everything, and all these database server historian. This is more critical than the corporate zone, because this is not directly impacting our process parameters or the production. So basically we need to see whatever zones or whatever devices are close to the process control, those are the more critical, those are the time sensitive network. But if some and in case of like, we need to see that if some system is down, what will be the impact on the direct production. So if let us suppose if this communication goes off between application server and this field location, so it will directly impact the production. So this might be this all systems failed, this becomes offline. So in that case, it will be a direct loss of view, loss of monitoring, and loss of production of the environment. But if let us suppose a business server or business workstation goes off, it will not have much impact, because already this is being a separate internal trusted zone and all communications are going inside it. But if this web server goes off, DNS server goes off, it won't have any impact on the production. So this is how we can segregate that which devices or which zone is more critical for my business, or which one is the less critical. So similarly, related to that, we need to put a proper firewalls, proper zoning model in our place. So this is about the restricted data flow, how we need to make a zone model, how to restrict the data. Now, how can we do? So basically, like we talked about the firewall, so there are basically three things which we can implement to achieve this segmentation. So we can do with the firewalls. So firewalls can be used to logically enforce user-defined rule sets of network traffic. So we can put network traffic rules like from IP address A to IP address B. If something is going on, it should be allowed. Or if from this set of networks, if this protocol, RDP protocol is accessed, then it should be allowed. If SSH from this location A to location B or zone A to zone B is done, it should not be allowed, denied. We need to make multiple rules like this only. So commonly placed at the network boundaries, as we saw in a previous picture, all these firewalls are placed at the boundaries as it is a boundary protection device. Firewalls can limit both incoming and outgoing traffic based on variety of characteristics. So there are types of firewalls also. So we have industrial application firewalls. So nowadays these firewalls can understand the industrial protocols also, like OPC, DNP, Modbus. So they can TCP, Modbus. So they can filter out based on those protocols also. We have next generation firewalls which has many capabilities like intrusion detection system, intrusion prevention system. It has application allow listing also. It has antivirus also. So nowadays firewalls have evolved. There are also on type of the basic topology of the firewall. The types of firewalls are like packet capture firewall. Those are purely dependent on the IP based rule. So if you need to put the rules based on the IP from AIP to BIP, allow this protocol, then it will be allowed. Then we got deep packet inspection. So these firewalls then checked each packet, what is inside the each packet, what type of message is there, what is the payload contents of the packet. But it took more computing power, and it as the functionality increases, the also the cost increases. So we need to decide like whether deep packet inspection firewalls are required or not. Then we have a stateful firewalls also. So that started understanding the state of the communications or the session. So let us suppose if terminal server is connected by a remote desktop from somewhere. So in that session, if something happens, then that is it takes a snapshot or control of that session. So it allows that activities only in that session only. And if session gets closed, then again new session, new identification and authentication need to be do again. So session aware firewalls are there. So those are also then pretty good. Then also there are types of firewall like application firewall, on which you can restrict even the applications. So if you want to do a restriction based on the application, so that can also be done in those types of. So moving ahead, like we discussed about types of the firewalls, and then VLAN is a very good tool if we want to just do logical separation. We do not want to invest much in physical hardware. Then VLAN can be used to logically separate areas within a network when physical segregation not feasible or due to cost or priority measures. So VLAN, what is VLAN? You need to search like on Google. You will find many explanation of VLAN. In short, I can explain that VLAN on a single switch or single firewall, you can make multiple networks on the single switch. So if you say that VLAN 1, 2, 3, 4, 5 I have configured, and one is for the process communication, another is for OPC communication, VLAN third is only for the data upload to Pi server. VLAN 4 is only for the backup. VLAN 5 is only for the management of the switches. So this is how on the single physical medium you can create multiple VLANs, and you can allot a specific bandwidth to each of these VLANs so that it can use the same physical medium, but all these communications will remain logically separated. So this is the concept of the VLAN. And this is a good method and proven method that we can utilize these things in for segmentation also. And only threat here is that it is susceptible to VLAN hopping attacks, but for VLAN hopping attack we need a physical access to that switch or firewall. So if we limit the physical access to that switch or firewall, then yes, we can somehow prevent the VLAN hopping attacks also. Then we discussed about the unidirectional gateways also. So unidirectional gateways are like one example is data diode. So you can send information from only one side to other side. So let us suppose if you have a system here in this zone 3 and you just want to send something to business server only one way, you do not want in reply. So let us suppose you have a log correlation engine here. So you want to just send the logs from this this zone to this zone. So you can put a data diode here and just uplink it to this corporate LAN. So in that case, what will happen? Only one-way communication will happen. So there won't be any threat from this way. So those one-way communications are like it is physically bond and physically separated. So there is no chance of any back communication because LED type of communication is from one way is only there. So if you search about the data diode, you'll find more details. But in general, it is like transmission in single direction. Like we can send syslogs, we can send FTP files from one way to another way. So those are some applications of unidirectional gateway. So this is all about the network segmentation. I think hope you understood why and how to do the network segmentation, what purpose it solves. So let's move to the next topic. To this topic, and this topic is like timely response to the event. So basically we'll talk about the events and the timely response. So requirement says that respond to security violations by notifying the proper authority, reporting needed evidence of the violation, and taking timely corrective action when incidents occur. So basically what does it mean? Like we need to have a proper method in place so it can detect all those violations against the baseline or against the policies whatever we have set up that need to be detected, and once it is detected we need to do a corrective action so for taking a corrective action we need some evidence, and that evidence will be the log events, incidents, that could be the evidence. So this is about the requirements. So what we can do monitoring of the remote access and communications to control system. We can monitor all the types of the remote access, whatever is happening from wherever, and communications to the control system and components, as well as file transfer operations. So if some file transfers are happening, we need to monitor them as well to help ensure that information and audit logs are accessed only from the authorized user. So we already studied about that use control, that audit logs for all these things need to be generated, and then it should be accessed by only the authorized user and workstations or any software program. So real-time alerts to be raised if unauthorized access and communications are detected. So wherever we are saving these audit logs and these events, those needs to be safeguarded by means of solution which can detect unauthorized access. So let us fail command, fail read command, fail fetch command. So these fail events. So these will give us the real-time alerts if something unauthorized access or these things happen. Then components shall provide the whatever solution will implement, that component shall provide the capability to be continuously monitored to detect. So continuous monitoring should be there. Continuous monitoring means 24/7 monitoring, characterize and report security breaches in timely manner. So whatever solutions are in place, so if it is an intrusion detection system, it should be in 24/7 in place, and it should keep on checking the traffic, keep on checking, comparing it with the baseline, keep on comparing with the policy and the rules whatever we have set in there. Then it should report if there is any breach, as per the policies whatever we have set. then it should create an incident or alert and send it to the SIEM or the centralized monitoring console. Monitoring can be achieved through a variety of tools. So like I said, that if we are putting IDS, so those techniques are there, like IDS, we can put IDS is the intrusion detection system. So what it does, it captures the traffic and it analyzes. Initially, it makes a baseline that this is the 10 Mbps baseline, and this type of communication flows in this from point A to point B. So that is the baseline. Then if something alter happens, something deviates from the normal routine traffic, some malicious activity or some malicious protocol, malicious IP address or malicious type of request goes into that traffic, it detects and raises an alert that this is the deviation from the normal traffic. So IDS we can implement. Then IPS also. IDS is intrusion prevention system. So we need to implement IDS in parallel. So it will not directly interfere to your communications. But if we implement IPS, intrusion prevention system, it is implemented in the series. So if it detects some abnormality, then it abrupts that communication. It halts that communication at the same point. It quarantines that communications or that protocol, or blocks that IP even. So some firewalls come with the IPS functionality as well. So because firewall is always implemented in the series communication, so it has that capability to block that ports, block that user, block that protocol, block that application. So this also we can implement. Then network monitoring mechanisms also, like there are network performance monitoring solutions from SolarWinds, Manage Engine, Cisco. They have different solutions. So what they do, they actively query all those network components in the system, and then based on that, again it has also rule set, compliance set. It has also the brain. It has machine learning and AI algorithms which can differentiate between the normal behavior and the anomalous behavior. So network monitoring mechanisms also give a good insight. It has the IP address management tools also, which can also see keep the stake of the all IP addresses of the environment. So if there is any anomalous or any deviation from the normal baseline, then it can detect from that. Also signatures are there in the IDS, so it can compare with the signatures of old virus, old malware. So in that case, if some malware or some virus or worm comes or rootkits comes into the traffic, then in that case that could be detected based on the signatures it has. So signature based detection is there, then anomaly based detection is there, behavior and anomaly based detection. So these two types of IDS IPS are there. We can make use of that. So let's move forward. So let's discuss about that continuous monitoring is the constant vigilance for external threats to your security controls. Continuous auditing is the constant testing of internal controls to make sure they are effective at preventive attacks or compliance failures. So we need to put a continuous monitoring in place which can check all the communications, whatever is happening in the network or on the endpoints also. Continuous auditing also we need to put so that we can test our compliance. So we have a set of compliance that this device is compliant, it has the data loss prevention module, it has application allow listing, it has antivirus, all are updated, backups are taken. So this type of compliance we can create, and against that solution or that software will check whether this device is compliant or not. So that is one type of the continuous monitoring we need to implement. So what are the advantages of this continuous security monitoring? So first advantage is that it will give you real-time visibility into your data, security data. So that is the real-time or near to real-time, we can say. So it will help you to prioritize and manage risk consistently across the organization. So once you have a continuous monitoring, you can constantly or consistently you can see the risks of your environment. You can prioritize your risk as well. Then we can provide cybersecurity metrics that can assess the state of security at all levels of organization. So we studied in Purdue level that we have level 0 to level 5, and even it goes to level 7 as well. So cybersecurity metrics that can assess the state of security at each level. So for each level you will get a security state. You can say that my level 2 is not much secure because we have not enabled application allow listing there. My level 3 is more secure because we have a industrial application firewall at below. We have all those systems are patched, all those systems are new, latest, and backups are taken. We have a business continuity program for that. Everything is there. So level wise we can see that what is the status of that level. We can get it in detail. monitoring the continued effectiveness of all security controls. So whatever security controls we have implemented, so we need to see what is the efficiency or efficacy of that control, whatever we have implemented. So we can monitor the continued effectiveness of all the security controls. So if we have implemented antivirus, so whether it is detecting all those viruses or worms, or it is preventing those in our network or endpoints as well or not. Then next is verifying compliance with information security or OT security policies derived from the organization, business functions, federal legislation, directives, regulations, policies, standards, guidelines, and best practice. So how do we make a compliance? Compliance is just a list of checks what we need to do against the business functions or federal legislation, or the national compliance policy or directives, regulations, or whatever we have. So it will check that your device or your network or the organization or process is compliant as per those checklist or not. So that can also be done by the continuous monitoring, and we can get a compliance report based on those policies what we have implemented in the solution. Then we have assuring that you have good understanding of and control of the system environment changes. So any change management, it is talking about the change management solution. So whatever change is happening there, are we making a good understanding? So all those change management process is following a procedure or not? So is it going through the permit? It is being authorized by the correct person or not? So whose signature is there? That auditing mechanism for the change management and approval mechanism for that change management is there or not? So change management is basically like if you want to do some changes in the system, that should go through a procedure. If you want to modify one logic, that should go through a procedure. It should first you need to take permit, then it will go to the approver, then second approver, then you will get a permit, then you disable the security or you bypass the security, then modify the changes, and then again revamp back what were the initial state of the system. So that is a complete cycle we need to follow with the all auditing purpose, that you in later stages you cannot say that I have not done these changes. Improving our awareness, threats, and vulnerability. So when we do all these things, obviously all this data, all this scattered data will converge into the information, and then we can say that yes, definitely it is improving our threat awareness. It is improving the awareness about our systems, our assets, and vulnerabilities as well. So that's all about the continuous monitoring and timely response to events. Let's move to the next topic. And welcome to this last FR, which is FR7, and this is the resource availability. So basic requirement is in just 2 lines: ensure the availability of control system against the degradation or denial of essential service. So basically we need to check whether components shall maintain essential functions in a degraded mode during a DOS attack. So what is a DOS attack? We'll see in next slide. So DOS attack is basically a denial of service attack in which the service becomes unavailable for some time or for a long time simply. So it shall provide the capability to report the current list of installed components and their associated properties. Solutions shall include built-in controls for real-time detection of several type of DOS attacks. Alert information includes details on the source and target host as well as DOS attack technique being used, enabling quick response before control system and components essential functions are compromised. So resource availability is basically we need to make our systems available in case of there is a DOS attack. So let's move ahead. We need to also in resource availability, it's in the similar point of direction where what we are thinking now. So it's about to avoid single point failure and redundancy, to enhance redundancy and fault tolerance. So we need to see like what is the scale of our organization and what could be the impact if it gets down. So if the impact is very less, then there is no need to think much in this direction. But if the impact is huge, like you cannot afford even a single second or single millisecond of shutdown, then we need to focus on the resource availability at a much greater extent. So single point failures can exist at any level of your control system. So because security is usually being added to the ICS environment, an evaluation should be done to identify potential failure points, and a risk assessment done to evaluate each point's exposure. So let us suppose if you have a server and it has only single power supply, so that could be a single point of failure. If you have a network and it has only a single link to connect all these controllers and to CPUs, to processors, to HMI and field controller, so that is called like a single point failure. In case if that link goes down, your complete communication will get cut off. So these are some examples of single point failure. So let us suppose if you have a server and in that there is no RAID configuration is there. So in case of the loss of the hard disk, your complete data will get corrupt. So that is also a single point of failure. So there are several single points of failure example which we can say. So we need to basically what is the best method to find all these single point of failure? We need to conduct a risk assessment, and based on the risk assessment findings, we need to pinpoint all those points of exposure. We need to check the cost versus impact analysis, that what will happen if we do not improve the redundancy of the solution, or what could be the impact in terms of the financial safety, health and reputation. So once those risk assessment, we need to prioritize the most impacted single point failures, and we need to improve them. So this is one way. Other thing is that the redundancy and fault tolerance, we need to ensure redundancy and fault tolerance once all those single point failures are identified. So ICS components or networks that are classified as critical to organization have high availability requirements. So we already understood that how we can find that which environment is more critical. So let's suppose that we identified some zones or levels as more critical, and then it should have a high availability requirement. One method of achieving high availability is thorough the use of redundancy. So if a server is more critical and it has only one power supply, so make it a 2 power supply, or just add one power switch which can have the 2 power supplies from 2 different sources, and then it can converge to a single power supply if it cannot be done. Or otherwise you can just add one more power supply if it is a modular server. Additionally, if a component fails, it should fail in a manner that it does not generate unnecessary traffic on ICS or does not cause another problem elsewhere. So cascading impact of one failure to another impact should be avoided, such as cascading event, we can say. So fault tolerance is the same, if there are 2 disks are there, each are copied to each other in a RAID configuration 110, or a RAID configuration 1, or RAID configuration 5, 6, or higher RAID configurations. Then in that case, what happens, even if your one disk fails, there won't be any impact on the other disk. So this is one example of fault tolerant. Or clustering, if we do in our servers, that is an example of fault tolerance. Now let's understand what is denial of service, because we talked earlier. So the definition of denial of service is that it is an attack meant to shut down a machine or network, making it inaccessible to its intended user. So it is a type of attack which exhausts your resources, making it inaccessible to any of the intended or users. So DOS attack accomplish this by flooding the target with traffic. So the main mode of attack is to flood the traffic, or sending it information that triggers a crash, or sending it such information that triggers a crash. In both instances, the DOS attack deprives legitimate users, that is, legitimate users are the employees, members, account holders, services, software services, users, operators, technicians, plant head, shift in charge, these user profiles of the service or resource they expected. So basically what it is doing, it is it is giving a type of loss of control on your control system, or loss of control. You cannot control your control system anymore, because it is crunching. It is creating a resource crunch by utilizing all those existing resources. It could be the bandwidth. It will full choke your bandwidth. It can do a network storm. It can or it can utilize all the existing ports of your computer. It can do increase your CPU load for beyond 100%, that it is not able to receive any traffic. It can full your RAM so that it cannot process any further information. So these are the types of the denial of service attack. So basically we'll see here three types of denial of service attacks. One is buffer overflow attack. So this is most common DOS attack. The concept is to send more traffic to a network address. So if you have a network address, attackers will send more traffic to network address than the programmers have built the system to handle. So there is a capacity of a system to handle some addresses, number of the addresses, but attackers, what it will do, they will send more traffic to address so that it can create a overflow. It includes attacks like ICMP flood or ICMP SYN flood. So these two types of attack can be done to do overflow attacks, in addition to others that are designed to exploit bugs specific to certain application on network. So these two, like ICMP flood and SYN flood. So what is ICMP flood attack? ICMP flood attack is leverages misconfigured network devices by sending a spoofed packet that ping every computer on target network instead of just one specific machine. So this is ICMP flood. ICMP is the ping message. So it will just give a ping command, but it will ping every computer on the network, but instead of just one machine. So this can be done if your network is not segmented properly. It is a flat network. So what attacker will do, he will just list the IP addresses from 1 to all, and then he give the ping command with a big packet size, and then what it will do, it will flood all your bandwidth, all your network, all these things with the ping command. The network is then triggered to amplify the traffic, because if ping response is not received, then it will keep on all these devices keep on pinging to each other in terms of finding the real devices. So this attack is known as SMUF attack or ping update. So once this is initiated, then your complete network will turn into a disaster, ending into the denial of service of the network services. Another is the SYN flood. So it sends a request to connect to the server but never completes the handshake. So continues until all open ports are saturated with the request and none are available for legitimate users to connect. So what it will does, if you know how TCP handshake happens, so in that there is a ACK, there is a SYN. So what it does, it will send only the SYN messages. So once SYN is done, the computer will keep on accepting, keep on responding or waiting for the ACK, but it will keep on accepting the SYN messages. So all the open ports will become saturated and none will be available for the any other legitimate users. So this is the SYN flood. So these are basically some types of the DOS attacks. You can read about these in details. There are lots of materials available on the internet also. Now another is the control system backup is also type of resource availability. So we need to keep the availability of the latest backup of PLC, control system, other application on system server, so that we can restore it within the recovery time objective, whatever is set by the organization. Centralized backup management systems are in place for quick restore. So if there is something happens, we need to quickly restore our servers, and it should be tested and validated, the process as well as the data. So it should be tested and validated. So there are lots of solutions available in the market, like Veritas is there and then Acronis is there. So we can implement any of these solutions, or there are some proprietary inbuilt solutions by Siemens, Honeywell, Emerson. So we can use that for their automation servers as well, and application servers as well. Otherwise, if something is not available, we can go for the commercially available of the self softwares like Acronis, Veritas, or VersionDog. So this is all about the resource availability, and we covered all the foundational requirements as per mandated in 62443. So this is a very good, like if you want to initiate or do cybersecurity in OT, you need to keep these FRs in front of you, and you need to design as per the risk assessment output. You need to define and design these solutions and implement, so that it will make it more secure. So this is the end of this module. We'll meet in next module. Thank you. Hello everyone and welcome to this new module. In this new module, we will learn about some basic technologies, what we can quickly implement in our systems or in our premises so that we can get a quick result and we can get a quick basic security at least SL1 what we can do. So let's start with some of the basic technologies what we can implement. So first one is the asset management. So this ability for the what is asset management? It is the ability for organization to, just let me get the point. So the ability for the organization to properly and consistently identify and consistently manage data, personal devices, systems, and facilities based on their relative importance provides a foundational capability to support an organizational security program. So this is the definition of asset management. So if someone says like what does asset management contain, it doesn't contain only the asset management, it needs an identification and management of data, personal data also, personals also, devices also, systems, facilities, everything whatever exists in the plant premises. So what are other specific features we need to check? So first is like unique identifiers, like you have seen the tag names in the plant. So there are several tag names, some follow KKS coding, some follow different tag names to identify the devices, pressure transmitters or thermocouples or even the workstations, network switches. So those are identifiers. So these are the identifiers we need for the tracking of assets as well as for inventory management. So hardware inventory management to track computing and network devices, including device details and location. So whatever network devices are already installed in the plant, so those device details and locations are required. Then software and firmware inventory management to track the software and firmware with version numbers and location information. So how many softwares are installed in my plant and what type of softwares are installed in the plant, and what are the version numbers, when they are going to expire, when they are going to become obsolete, when we need to update it, when the license will get expired. So those all specific informations are the part of the asset management. Then we need vendor information to establish a repository of vendor information, points of contact, warranty information, locations of recall, update information. So all information related to the vendor. So if we are using some products of the vendor, we need to keep track of all those informations about the warranty, locations of recall, or if some product needs support, so how can we get the support, if we need some replacement, so how to get that. All those procedures information need to be put in a single place. Then next is documented roles and responsibilities to identify specific individuals, teams, or organizational groups who represent the asset owner and those with operation and maintenance and cybersecurity roles and responsibilities. So this is about the documentation of everything, all the roles, responsibility, governance of the organization, who owns what, who is responsible for what. So those type of documentation is required. Then other things what asset management contains, those are like device discovery and protection. So there are several automated tools for device discovery also. They can discover your devices, they can do a baselining of devices and also protection of the devices. In case of someone plugs a new device in your network, those can be identified. So these type of solutions are available. Then we have vulnerability management also. So some asset management solutions, if you see in the market, they have the vulnerability management also. So they can pinpoint the product specific vulnerabilities which are published or researched in some the document or in public forum or by the OEM. Those information you will get by the asset management solutions also, though it is not the dedicated part of asset management, but nowadays we can see it's a complete suite. It is coming from the vendors and they provide all these sorts of capabilities. Then one important part of this asset management is change management. So if there is some change in the assets, so those related information can also come into the picture. So that those information will also get, like if some firmware got updated or if some device got updated or if some backup or configuration files are updated. So these sorts of change related information, or even asset management sometimes does have the functionality for approval mechanisms also. So we can use it as a change management and versioning tools as well for softwares also. And then obsolescence, like we discussed that asset management can keep track of the when this software is getting expired or when the support is getting finished, and what could be the license period and when it is getting terminated. So all these records are continuously monitored, and we can get a good insight of all our assets, asset health, with the with this respect in terms of the obsolescence as well. Then finally the disaster recovery. So if we know the status of all our devices in the plant, then definitely we can avoid some of the disasters as well. So if all the devices are healthy, it will definitely contribute as a disaster recovery. But if these devices and softwares and solutions are not known to us, then we cannot perform a disaster recovery. So let's move to the other next part of the asset management. So if you see a picture on the right side, you will see that many things are associated with the asset management. Asset management is just not a purpose to create an Excel sheet or some CMDB to keep the list of the assets or the inventory of the plant. It has multiple roles to do. As we discussed, like asset management, definitely it will have the asset inventory. So asset inventory can be connected in three forms. It could be import, it could be active scanning, it could be a passive scanning. Then we talked about the change management. So change management can be a part of asset management also. It can give up data to change management tool also if it is there. Then we can know about the vulnerability status of the devices or the assets. We can apply patches. So it will help in vulnerability management as well. The communication between various components within the asset management and detection will be also important. So let us take an example. So there may be an existing asset management or change management application that doesn't have an active querying capability. So if you have change management or vulnerability management solution and it doesn't have the capability of active querying your network, then that would want at least asset inventory from one of those new products. So, and many, if not most of the current competitors in the ICS detection market have strategies to forwarding the security event to SIEM rather than becoming a SIEM. So we check like how asset inventory or change management or vulnerability management can give input and can take some inputs from asset management also. Obviously, if asset management is smart enough to generate logs like of the changes, whatever is happening in the network, it can forward all those security logs to a log receiver. Also, it will help in endpoint protection management. So it will tell you the details or status of the antivirus, or if you have EDR installed, or if you have any other application allow listing installed, it will give you status of all those applications as well. Unauthorized configuration changes, so this can come into the change management. Then passive network detection. So these asset management tools keep on checking the network for the changes. It takes some traffic also, sometimes in passive, sometimes in active. So depending on the situation, it can collect those information, and then further it can pass everything to the OT or SIEM. So once all these data can go to the SIEM, we can have a good correlated output, and we can see like what changes is happening in the network and how it is contributing. So basically what we want to understand, we need to understand that asset management is a very good solution and basic application, because we need to know what we have, then only we can protect our systems. So basically we need to know like what elements consist of my inventory. Even if we have a Excel sheet or CMDB, that could be a basic way to start the asset management. But definitely for the higher security levels, we need to go for the automated solutions, and which could be integrated to vulnerability management, change management, SIEM solutions, so that it will be a holistic cybersecurity approach. And then, because asset management could be a good input for all other solutions whatever we can implement. So that's all about the asset management. Let's move to the next topic. Thank you. Hello, welcome to this chapter. This is about the segmentation. We have studied about the segmentation. So segmentation is basically what it does. So segmentation divides the computer network into smaller parts. The purpose is to improve network performance and security. So how does it improve network performance? Basically by segregating the bandwidths. Other terms that often mean the same thing are network segregation, network partitioning, and network isolation. So all these terms are same, and main purpose is the segmentation. So segmentation, basically it works by controlling how traffic flows among the parts. You could choose to stop all the traffic in one part from reaching another, or you can limit the flow of traffic by source, destination, and many other options. So now I think after so much discussion on segmentation, it must be clear to you that what is the main purpose we want to achieve. So we want to keep our system secure, as well as we want to improve the network performance. So let's see some of the more benefits of the segmentation. So one could be improve operational performance. So how does it happen? Segmentation reduces network congestion. So let us suppose we have one flat network and every device can reach to all the devices. So in that case, there will be unnecessary communications from one network to another network, or one network device to another network device, because you have a flat network. There is no segmentation at all. So even in case if you want to send something, or you want to fetch something, there could be some of the broadcast traffic. In case if you want to search or do a nmap scan, or you want to scan your network, it will create a huge amount of traffic. So this is how, if we segment our networks into smaller segments, like we can keep one office network, we can give one enterprise network, then it will definitely add the value to your network. Next is the protect vulnerable devices. So how can it protect the vulnerable devices? Segmentation can stop harmful traffic from reaching devices that are unable to protect themselves from attack. So let's take an example. A hospital connected infusion pumps may not be designed with the advanced security defenses. So network segmentation can stop harmful internet traffic from ever reaching them. Another example we can take of safety instrumentation system. So might be those solutions, they can't be equipped with super cybersecurity technologies, or they will not have such resources to implement all those cybersecurity solutions. In that case, what we can do, we can keep all these devices in a safety zone, and we can put boundary protection devices with a minimal exchange of data with the upper segments or other segments. So in that case, those safety zone will remain quite secure by doing the segmentation. Another example we can take that vulnerable devices, it could be the old or obsolete systems, or the XP systems, or the old obsolete switches or firewalls. So what we can do, we can keep all those devices in a different segment, and we can put a proper boundary protection cybersecurity control, so that the communications, whatever going inside that segment and are coming outside that segment, that should be inspected, questioned, and untrusted, and should be monitored every time. So that will help you to protect your vulnerable devices. Moving ahead is the reduce the scope of compliance. So segmentation reduces the cost associated with regulatory compliance by limiting the number of in-scope systems. For example, segmentation separates the system that process payments from that doesn't. That way, the expensive compliance requirements and audit processes apply only to in-scope system, not the entire network. So that is how, by these four factors, we can gain advantage from segmentation. Now let's see in this example. So we are aware of this architecture. This is a Purdue model of a basic DCS we can consider here. So here we have created one segment, and in this segment we have kept all our physical interfaces. So this is a complete segment. Now after this, there is a one more level here. We have PLCs, HMIs, process controller, HMI. So these two levels we can consider as one segment. So whatever communications is going from this to another segment, we can put a firewall here in this place. We can put a layer 3 switch with access control list, which can control the communications from these devices. We can put a proper cybersecurity measures for this arena. So we can put proper physical security controls. We can add proper lock and keys, and we can also put some of the antivirus, anti-malware software solutions in the HMIs. But same is not applicable for this segment. You can see that here we have engineering workstation that could reside on the Windows, that could be a XP, that could be a Windows Server also. So different cybersecurity requirements will be for this thing. And in terms of the improving performance, so if this segment is in a different VLAN, so communications happening between this PLC to this PLC, or this PLC to this PLC, or from this HMI to this HMI, that will be totally independent of whatever is happening here. If there is some command going from engineering workstation to this, that will be in a separate segment. So that communication will not impact any communication between PLC to process communication. So what we can do, we can create one VLAN which will help to communicate these from peer-to-peer communications, or we can create a different hardware network also. So that we can call peer-to-peer network. So in some of the systems we saw the peer-to-peer networking. So what it does, it is a complete separate segment which communicates to each other on a separate segment. So similarly in the Foxborough DCS also there is a mesh topology. Mesh is for the controller communication, that is purely for the process control. And they have a above all communication that is called PC LAN communication, where the PCs, computers, are communicating the controllers. So two different segments are there, and also there are some pin segments are there where the communication from the above systems to these workstations or these controllers are happening. Though that is a completely different network. So we can create multiple networks in the same environment to ensure the non-interference between all these. So this communication will be separate, this communication will be separate. So any communication from workstation to historian, it will be again separate, and that all traffic will be determined by whether we can put a router here or we can put a firewall here. So firewalls are the basic thing which provide the segmentation. We can achieve that by router also, and layer 3 switches also using access control list. But best way to do segmentation is the routers, is firewalls, and then VLANs. So these two things we can do. And also if there are some communication going from this level to the internet, we can use unidirectional gateways. So that will also add a sufficient way of protection to our network. So unidirectional gateways also give a segmentation, because the unidirectional gateways act on a physical platform, that it gives you only a one-way communication. So that is how we do segmentation. So we talked enough about the segmentation. Hope it clarified you what is the purpose, what improvements it can do to our network, what type of cybersecurity benefits it can provide. So like in cybersecurity, let us suppose if some malware comes to this segment, so it will not cross-proliferate to this segment, because we will put here a firewall, we will put a firewall here, and these are totally different networks. So it will not segment without a proper routing rule through the firewall. So this is how we can limit the spread of malwares also in our system by doing segmentation. So that's all about segmentation. Let's move to the next topic. Thank you. Hello everyone and welcome into this chapter. This chapter is about the network discovery. This is not a cybersecurity control or a technical control we need to implement, but this is the sub part like being utilized by many of the cybersecurity controls. So if we install intrusion detection system in active query mode, it will use network discovery technology. If we put asset control mode, but asset management technology, but again that in active query mode, then this will it will use the network discovery protocols maybe, or network performance monitoring, or IP address management, or configuration change management. But all of this will need this network discovery. So let's understand what is this network discovery. So basically network discovery is a process that allows computers and devices to find one another when they are on same network. So even if processes are not running in some protocol, some tools like IDS or asset management or network performance monitoring, this type of tools are not running on the system, even some devices keep finding each other, keep checking the heartbeat of devices which are in their adjacency. So if you see like some controllers, they also keep on checking like who is beside me, who is adjacent to me. So they use multiple protocols, like they use LLDP protocol, they use ping, they use SNMP protocols. So basically there are three primary discovery protocols which can be used in automatic mode or maybe in a semi-automatic or manual mode also. So first is the simple network management protocol, SNMP. This is a quite common protocol and it has multiple versions also. So SNMP has SNMP v1, v2 and v3. So v2 and v3, they have more security features. Like in v3 you need to add your username, password, passphrase, as well as some certificate or encryption also. But SNMP v1 is quite a simple protocol, and it is unsecure also. But basically this is one of the primary discovery tools. So second is the link layer discovery protocol, which is also called LLDP. And don't get confused it with LDAP. LDAP is a different protocol that is for Active Directory. So this is a LLDP, this is link layer discovery protocol. And third one is the ICMP. So it is a ping message, what we say, but this protocol is ICMP. Now SNMP is an standard protocol that allows teams to aggregate and organize data about the devices on the network. So SNMP is used in many of the tools, whatever is available. So they use SNMP polling. So what does like SNMP finds these devices, and those values of the devices are kept in a OID table, and we often query that OID table using the SNMP protocol to get the details. Like if you want to get the name or host name or CPU loading or memory percentage usage or the hard disk availability, all those data, whether it could be an endpoint or it could be a network device, it queries in this protocol to get all those details from that device. Moving ahead is the LLDP. LLDP is a vendor neutral protocol. So if LLDP is enabled on the device, it will transmit device information. So regarding the enabling, so if you go to Windows services also, you will find that there is a SNMP service. You need to enable that service. Similarly, in switches also you need to enable that thing, then only these things will work. Without enabling this particular service on the network device and the endpoint, this protocol will not help you to communicate or fetch data. So similarly, LLDP is enabled on device and it will transmit device information to its directly connected neighbor during regularly scheduled intervals. So as I said, like whenever we connect multiple devices in a conjunction, then all these devices try to identify each other at a regular interval. So this protocol is being used. So if you want to see this thing, take a Wireshark dump of your ICS network and you will find many LLDP communications are happening in your network. So the neighboring devices store this data on management information databases, that is called also MIB databases. And when we query this MIB data with MIB browser, then we can get a list of all these devices along with their MAC ID, or there are several other informations will be available there. Coming next, ping is a very different from SNMP and LLDP. It is a software utility that teams leverage to test the reachability of the devices on IP network. So this is the common, like in general practice also, if you want to find some device or some computer where it is situated, it is on network or not, then we try to ping that device. So it does this by sending a internet control message protocol queries and measuring the round trip time of the message sent from originating host to the destination computer and back. So it measures time also. That TTL is mentioned in whenever we do ping messages, a time to leave is there. And if you see, there is a variation. Sometimes it comes to 64 milliseconds, sometimes 164, 128, or it's a 256 also. So that time to live determines like what is the round trip time of a packet to go to that device and then come back again. So similar to ping, there are trace route commands are also there. You can utilize that, also utilizes same ICMP packet protocol to find the route of the communication. So this is about the network discovery. So what is the purpose of network discovery? So main purpose of network discovery is to create a map of your network, automatic generation of the complete network map, and then some of the solutions whatever is available in the market like Nozomi, Clarity, Darktrace, Drago. So these are the solutions, Industrial Defender. So they also create a complete network map of your infrastructure, and then you will see that how many devices are in my level 1, and then how many devices are in my level 2 or level 3 or other further levels. So basically these solutions, whatever is available, they do both type of query. They do active query, they could do passive query. So first these solutions will try to map your network using the passive technology, so it will not directly interfere to any endpoint. But most of the time what happens, like not all the devices are communicating every time. So we need to do the active query also to get the accurate information. So for active query, what we have to do, we have to connect this network performance monitoring into the active network so that it can call that device. Yes, there could be interference on your control system network as well. But if we restrict or limit the number of queries, and we can check how much bandwidth it is occupying, then it will not impact the performance of your system as well. So with passive and active querying, we can create a complete accurate network map, and we can see like which interfaces has what type of communication happening and how much network loading is there. So if there is any higher network load on some segment or between two devices, we can pinpoint that. So basically network device or network discovery is a technology or solution which can give you complete network related insights. So you will get all those insights related to your network, firewall, network device, endpoints, communication bandwidth, CPU, RAM usage, your logs, and so multiple things, multiple insights you can get. So there are some major challenges also in this network discovery. First is that in some of oil and gas or in some critical systems, you will find there are air gap system. So you cannot do anything with the air gap system, that is already it is isolated from the main network. So with limited network connectivity and spanning across multiple networks, discovering these networks is most critical job. Then we always want the full coverage of our system. So there are other IT asset management tools out there, but again most rely on the credentials or endpoint agents to effectively inventory and map networks. Deployment is complex, and results do not include unmanaged devices. So might be there are some systems which are already obsolete and they do not respond to the queries initiated by the latest network discovery tools. So full coverage is sometimes not possible, but at least if we can reach to some optimum level of coverage, then after that some tasks we can do manually also. Then moving forward, system failure. So system failure, there is a possibility that if we use active querying, there could be system failure due to that old devices, or they can become a victim of a DOS type of attack if we do multiple querying without restricting the number of queries or restricting the bandwidth utilization by these devices. So what could happen, like if system failure happens, then it could lead to human injury, environmental disaster, damage equipment, physical process dot, so all of which could impact large portions of the population. So this is the thing, that this is the fear in our ICS community, that if we do active querying, there could be a chance of system failure. So what we can do for this, we can test the solution for a very small network, and then we can divide our complete network into smaller chunks, and then primary, secondary. We have two networks, we can go with the first secondary, then we can go with the primary. So if we reduce the exposure of the network which could get impacted by this type of solutions, then we can definitely avoid this system failure, and we will have a very good output which can help us to create the network map, and we will have a good insight of the data. So this is the purpose of network discovery, and hope you understood what is network discovery and why it is required and what type of protocols we use. So that's all about the network discovery. Let's move to the next chapter. Let's talk about intrusion detection system. So what is intrusion detection system? Earlier also we have talked about this. So an intrusion detection system is a monitoring system that detects suspicious activity or deviation from normal behavior and generates alerts when they are detected. Based upon these alerts, a security operations center or analyst or incident responder can investigate the issue and take appropriate action to remediate the threat. So this is the definition. Let's understand what are the type of IDS. So one could be host based IDS and another could be network based IDS. So host based IDS is deployed on particular endpoint and designed to protect it against internal and external threats. Such an IDS may have the ability to monitor network traffic to and from the machine, observe running processes, and inspect the system log. So host based IDS is a IDS which sits on an endpoint. So let us suppose if a computer is there, on that you can implement this host based IDS. It will check all the files, it will check all the processes, whatever is running, what type of activity these processes are doing. If there are some communication going on that host, if there is a communication happening between the application and system software, application and the network, those all type of communication will be tracked and from the machine only, and will inspect system logs, and in case of any deviation from the baseline behavior, it will initiate an alert. Another type is the network based IDS. So a network based IDS solution is designed to monitor an entire protected network. So it has visibility into all traffic flowing through the network and makes determinations based upon the packet metadata and content. So it will capture all the network traffic like you have seen here. Earlier we discussed this network architecture. So all these dots are the IDS sensors. So this will pick up all the communications whatever happening between, let us suppose if we take this one, so email server to it is going to external communication infrastructure. So whatever communication will happen through this, complete network capture will go to this IDS, and then it will analyze what type of traffic is flowing, what is the data inside that traffic, how this communication can be a vulnerability or can be a exploit to our system. So that will be found based on the signatures or based on the created rules. So there are some detection methods of IDS also. Like I said that it can detect based on the signature also. So there are basically three modes of detection. One is signature detection, another is anomaly detection, and third is hybrid detection. So signature based IDS solutions uses fingerprints of the known threats to identify them. So if there is already some known malware, so it will keep a signature of that malware, and once malware or other malicious content has been identified, a signature is generated and added to the list used by the IDS solutions to test incoming content. So this enables an IDS to achieve a high threat detection rate with no false positives, because this is just a direct comparison like antivirus does. So similar for malwares also, because all the alerts are generated based on the detection of known malicious content. So already it is known, it's not a zero-day attack, so it can find those signatures quickly. However, a signature based IDS is limited to detecting known threats, is blind to zero-day vulnerabilities. So what is zero-day vulnerability? Zero-day vulnerability is that some malware or ransomware or virus on the internet or threat on the internet which has not been exploited or which has not been in the network prior to this. So that is a 0 day. So it means like is the 0th day of that malware on the internet or for that system. So there is no any known signature available for that malware. So that is called a 0-day attack. And those are very costly and can be created with very huge resource and huge compute capabilities and also technical skills. So that is called signature detection. Now coming to the anomaly based detection. Anomaly based IDS solutions build a model of normal behavior of the protected system. So it builds a model of the normal behavior of the protected system. All future behavior is compared to this model, and any anomaly are labeled as potential threats and generate alert. So it is based on like machine learning and AI algorithms. So it will create a model and it will baseline your system as per the current normal operating system, and then if any deviation happen in the behavior of some traffic or some file or some process, it will It will find the potential threats and can generate alert. While this approach can detect novel or zero-day threats, the difficulty of building an accurate model of normal behavior means that the system must balance false positive. False positive is incorrect alert, and false negative misdetections. So this system is now maturing, and it's enough mature now. So most of the IDS solutions, if you find, they have a very good detection capabilities and very less false negatives also. So these are the two types of signature and anomaly detection. Now there is one third type, and this is quite good. It is hybrid IDS, uses both signature based as well as anomaly based detection. So it will work on this signature based also and then anomaly based also. So this enables it to detect more potential attacks with lower error rate and using either system in isolation also. So hybrid detection is a recommended mode to implement in any environment. If your environment is really large, you should go for the hybrid detection tools. So that will give you like both. It will be in learning mode also, and then it will be in detection mode due to the signature based detection capability as well. Now moving ahead, let's see, it's a basic thing that what is IDS and what is the difference between IDS and IPS. So how can we install a IDS? So let's see, this is a malicious hacker or user, and this is the internet, untrusted network, and then we have a firewall as a boundary protection device. Then we have a switch. Then what we will do, we'll configure a mirror port on this switch, and then mirror or a span port, and then we'll feed that mirror data to the IDS. So IDS will analyze all those traffic, whatever is passing through this switch. Then management is also connected to this, and there is a corporate network. So this is the point where we can check all the traffic coming from untrusted network to our network, but all the traffic, one copy will go to this IDS. So here IDS, you can see it is getting only the span traffic. So even if a threat is detected, it will only create an alert. It has nothing to do. It cannot prevent that to happen. So IDS is a detection tool basically. Now coming to the IPS, it's the same network, similar network. We are putting IPS in series. So after firewall, there is a IPS solution. Some firewalls like next generation firewall, they have IPS inbuilt with that. But you have an option to keep that IPS in a monitoring mode or in a protection mode. So if you keep that IPS in a monitoring mode, it will become IDS. If you keep that IPS in a protection mode, it will become protection. So what will happen here? So if something comes out here, some threat or malware it identifies, it will block that traffic to go downwards. So it will prevent that threat to further propagate into this network. So IPS is quite good for the systems where there is no any downtime in case of blockage of the traffic. So let us suppose if this is your industrial network and you have implemented a IPS, in case of the false negatives, this communication will break and there might be performance issues in your industrial network because that was a false negative. Like that was not actual alarm, that was just this system is not matured enough to detect whether it was a false negative or false positive. So in those cases, it is recommended to install a IPS in a monitoring mode, in a detection mode. And once your system gets matured, it has good learning, then you can switch it back to the protection mode. So that is one basic implementation of IPS. Now hope you have understood difference between IPS and IDS. Similarly, you can create it you can put it on a big network also, like we saw here. Now we have multiple IDS sensors, and all these IDS sensors will be connected to a central console where you can see all the alerts from everywhere. It is not like distributed. So IDS consists of basically sensors. It will have sensors, it will have a central computing module, it will have a threat engine, it will have a display also where you can see all those centralized threats, centralized detections. Then yes, there is an option to integrate it to your SIEM solutions also, so that you can correlate all those events whatever being generated by the IDS and then compare it with the other logs whatever we are collecting from the endpoints and other places, and so that we can monitor everything in a whole. So this is all about the IDS. Let's move to the next topic. Thank you. Hello and welcome to this topic. This is SIEM solutions. So what does SIEM stands for? It stands for Security Information and Event Management. So this technology supports threat detection, compliance and security incident management through the collection and analysis, both near real time and historical, of security events as well as wide variety of other events and contextual data sources. So SIEM is always accompanied by log management solution. So we'll see like how it does work. So the core capabilities are broad scope of log event collection, log management, and ability to analyze log events and other data across disparate sources, and operational capabilities such as incident management, dashboard, and reporting. So SIEM can be seen as a centralized tool which is accumulating all the logs, alerts, and then it gives the insightful data to the user so that he can have a look on the complete enterprise or infrastructure, like what's happening where. So basically it has multiple functions. One is alerting. So it analyzes events and helps escalate alerts to notify security staff of immediate issues either by email or other type of messaging or via security dashboard. So it will analyze all those logs, because if you see in an environment, the log generation has increased beyond the manual limit of understanding the logs. So we need a solution which can analyze all those logs. So logs are generated around like 5,000 EPS, events per second. So it is impossible by a human to see all those logs and then derive some sequence between them and some logic between them. So we need a SIEM solution which can analyze all those thousands and hundreds of thousands of logs and convert them into the alerts. So an alert can be created by analyzing multiple logs as well. So if let us suppose if there is a multiple login failure at a device, so we can say that an alert can be generated that unauthorized access for this device is done. So that could have come from the 5 unsuccessful login attempts also. Then it has dashboard and visualization. So it creates visualization to allow staff to review the event data, see patterns, and identify activity that does not conform to standard process or event flows. So what we cannot see with our bare eyes, those type of information it will provide in terms of visualization, and by analyzing the event data, the log data, and then creating a pattern also, pattern of attack. It could be a pattern of the change in the process data or change in the network data. So those visualizations we can see. Then retention. So one functionality of SIEM solution is also retention of the logs and events and alerts. So stores long-term historical data to enable analysis, tracking, and reporting for compliance requirements. So it stores long-term historical data. So let us suppose some organization has a retention data of 5 years, of 1 year, or 90 days even. So it has a functionality that it can store that data for such a long term as well. Especially important in the forensic investigations which can occur long after the fact. So if something happens at the latest stage in the plant, so that could be detected by the stored logs, whatever we have stored. So it will help in the forensic investigations if some attack happened or some type of trials is required. Next is the threat hunting. So allows security staff to run queries for multiple sources via SIEM data, filter and pivot the data, and proactively uncover threats and vulnerabilities. So threat hunting is a manual activity or a assisted automated activity also sometimes. So it will help, SIEM helps you to give the all sorts of logs on a single database, and you can do all those query sorting, and you can find the bridges between all those data. So now you have logs from switches, from firewalls, from asset management system, from configuration management system, from the log management systems, and from IPS, from IDS, from switches, from workstations. So you have now multiple logs, and it is all at the SIEM solution. So you can just do a query and you can see that at a particular timestamp what happened with all these devices, and you might find a link. So that type of activity is only possible if everything is at a place and in a well visualized manner. So it helps in threat hunting also. Next is incident response. So it provides case management, collaboration, and knowledge sharing around security incidents, allowing security teams to quickly synchronize on the essential data, communicate, and respond to threat. So some of the SIEM solutions and most of the SIEM solutions, they have the incident response also. So you can directly integrate your SIEM solution to a ticketing solution, and then in case of the incidents, you can raise a ticket and you can assign the authority or responsibility to a particular person to resolve it. And also it is a communication tool, so you can provide the details of the event what happened to a responsible stakeholders. So these all type of capabilities are lying with SIEM solutions. So there are several SIEM solutions out in the market. It's like we have Splunk SIEM solution, we have Exabeam, we have Logarithm, we have 40 SIEM, we have IBM SIEM, then Secure Running. If you download the Gartner or top SIEM solutions, you will find a list of SIEM solutions. So Elasticsearch is also a SIEM, they have also a SIEM solution capability. So in picture we want to see, we can deploy this SIEM solution either agentless or agent based. So what is the agent? Agent is a software which sits on a system that it will collect all the logs of that system and forward it to the log management or log collector. So let us suppose this is a server. So one SIEM agent can sit here if OEM allows. In OT system, we need to take approval of OEM prior to installing any agent or changing any service or any DLL file even in on the servers or the workstation or HMI. So with vendor or OEM, we can discuss for this how much data it will consume, how much bandwidth it will consume, how much CPU resources it will consume, how much hard disk it will consume. So we need to see all those things prior to putting an agent on any of the systems. Yes, some systems which are monitoring, that can also be there we can implement agent if it is approved by vendor and it is not in the time sensitive network, so that due to the degradation of the performance of that system or that switch, there will be some direct impact on the production loss. So SIEM agent will sit on workstation. Then we can also put SIEM agent on wireless servers, then SIEM agent on the mobile devices if organization is using SIEM agents on the surveillance systems. Or if some systems they do not allow you to put an agent, then in that case we can use agentless method. So we can use Windows evading method, we can use SNMP trap forwarding, we can use syslog forwarding. So there are other methods also where what we can use to collect the logs. Then all these things will go to a log collector. At the SIEM server, there is basically one correlation engine. So correlation engine, what it will do, it will correlate the logs from each of these devices, whatever, for a particular time span, and it will try to find the exact relation between the logs or the events. Then it will have a database where it will store all those events, alarms, and logs, also the incidents. Then it has a security intelligence engine also. So what it will compare with some security intelligence, the alarms or the correlated output what it generated, and it will try to figure out whether it was a really an incident or not. And then in case if it finds that was an incident, it will notify to the user. It could be SOC analyst, and then SOC analyst can do their due diligence. We can also export and import everything whatever is on a SIEM server. We can sometimes put a redundant SIEM server, we can put redundant communication links to make our system robust. So only just putting a SIEM solution doesn't meet the security purpose. You need to put a team there or put a solution there to see what is actually happening there. Just by putting a SIEM server, it will only help you in forensics. But if someone is there to see what is actually happening here, to check, to do the threat hunting, to visualize whatever is happening there, then only that SIEM solution will be useful. So that's about the SIEM solution. Let's move to the next topic. Thank you. Hello everyone and welcome into the last topic of this module. So this is the endpoint protection, and endpoint protection is a broad term. So it contains many things. So what is called endpoint protection? Endpoint protection involves monitoring and protecting endpoint against cyber threats. So let me revise it again. Endpoint is any computer, any HMI that contains an operating system and application software running on it, or some sort of OT application software. So that is called an endpoint. So we need to protect our endpoints against the cyber threats. So protected endpoints include desktop, laptops, smartphones, tablet computers, and other devices. So various cybersecurity solutions can be installed on and monitor these devices to protect them against cyber threats regardless of where they are located. So basically, this is the definition and understanding of endpoint and endpoint protection. So what could we install on the endpoint? So, and why it is required? Because whatever solutions we will implement on the endpoint, that will be the last line of the defense. So it means that all the covers whatever we have installed as a perimeter security, as a detection mechanism, as a prevention mechanism, as a shielding mechanism, as a physical access control mechanism, when all those things are bypassed by the adversary, then they have to bypass, or they have to intrude the host also, to intrude the endpoint also, in position to install a executable on the system, or disable the executable on the system, or they need to escalate their privilege on the system. They need to, even this is the last line of the defense, whatever we are putting on the endpoint, and they need to intrude or bypass that as well. So first is the anti-malware. This is the oldest we have seen, like antivirus. So that is the anti-malware systems, which should detect and prevent infections by viruses, worms, and other malwares. So this was evolved very early, and we used to install all these things in industrial systems. So they are a sort of approved. So we often run Symantec antivirus, or we run Norton antivirus, or as well we run McAfee antivirus or anti-malware systems. Now we have multiple module of that antivirus. It doesn't have only antivirus capability. So they have anti-malware capability, they have anti-worm capability, they have all those signatures of the existing threats which has been released till date today, and they gets on updated on very often rate. So whenever we install an antivirus on the system, or we can say anti-malware on the system, we need to keep the signatures updated. Then only we can ensure that my system will remain protected from the available viruses, malwares, and the worms. So that is the first thing what we can install on our endpoints for endpoint protection. Next, we can go for next generation antivirus. So next generation antivirus is to combat new forms of the malware, which has machine learning and behavioral threat protection. It was introduced to create more effective next-gen antivirus. So we can go with the NGAV. It has like some behavioral capabilities also. It can understand the behaviors, like how processes are acting. Where if process gets infected by a malware, then they will behave in a different way. So these or the pattern of the signatures, if some signatures are very new and it cannot identify, on the basis of the behavior of that signature or the malware, it can predict that, okay, this is the one of the type of the viruses, or this is replicable, or this is a worm, or this is a rootkit, and they can prevent it from executing and proliferating inside the environment. Next, moving is the endpoint protection platform. So then it come an era of EPP, and EPP combines antivirus, next-gen antivirus, personal firewalls, encryption, USB device control, vulnerability assessment, and more to deliver a full platform to stop malware from penetrating endpoints. So often at today's date, we are at this stage. In most of the applications or most of the industrial workstation, you will find some sort of this type of technology, or even older than that. You will find only antivirus, you will find antivirus or anti-malware, this type of system. So current stage, if you see research, if you see outside the plants, if you ask to your friends like what type of solutions they are using, you will find almost this type of solution. They will have a USB control for data loss prevention on each of the devices. They can control, they can disable the USBs. They will have one personal firewall enabled, so there is a already Windows firewall is there. Sometimes whatever solution we implement, they have also some firewall, like McAfee has their own firewall, so you can enable that firewall also. They have encryption capabilities also, so like in our personal computers we do like a bit encryption, so similar type of encryption is also there. Then apart from them, these two will be there, anti-malware, antivirus. Then also EPP will have some application allow listing and application block listing type of functionalities. So all these, there is a composite suite of the applications which will have a centralized monitoring. You can see everything what is happening on all the endpoints on a centralized console. You can deploy all the agents, you can deploy all the patches of this application from a single point. Then moving ahead, one advancement is the EDR, so endpoint detection and response solutions. So these tools are primarily focused on detecting and investigating suspicious activity on endpoint. This name had evolved to endpoint detection and response. So this is the latest what is coming in the market now. If you see, some of the companies are also accepting this type of solution. Only problem with these type of solutions is the installation of agent. These solutions will not work without installing a agent on the workstation or HMI, so or server. So if you install an agent, it should be tested with the OEM. Otherwise, it will interfere with the performance of those applications and it can cause loss of availability of those solutions. So it is always recommended to check with the original equipment providers like Honeywell, Siemens, where they are supporting this type of solutions on their platform or not. If we are installing it on a monitoring platform or monitoring solutions which has been provided by none of the OEM, it is the sole and proprietary of the customer, then they can definitely go for that. So this solution comes with a response part also, and automated response is not always welcomed in OT environment or in ICS environment. So better to disable the response part or keep it manual. So like in some cases, if something is getting detected, so alert should be raised and manual action can be taken. Then moving further, some companies released an XDR also. So XDR is considered as an emerging technology that is quickly gaining traction in the endpoint security market, and it is called extended detection and response. So we have to see like whether OEMs or the solutions or the OT ICS market is accepting these things or not. So everything depends on how interference and how resource consuming these all technologies are. So till now today, some of the companies are accepting this EDR and we are implementing, but till here it's all tested, and most of the organizations, most of the solutions, they are okay with these things. So you will find these three things in most of the solutions, but you will find EDR on the some of the solutions, and XDR it's a very rare because it's an emerging technology. So that's all about the endpoint protection, and it's the end of the module. So let's move to the next topic. Till then, thank you. Hello everyone, and congratulations that you have completed this course and all the modules. So now it's time to conclude and summarize. So what we studied in past few days, or if you have finished in just one day, that's ultimate. So let's go one by one, like what we studied, and we'll see. So we started with the DCS architecture, and then we saw like how what components are there in DCS, and how it is look like, how many architectures are there, how many types of architectures are there, how can we place all this DCS in Purdue model. Then we saw some type of DCS examples also, like from Siemens, then from Yokogawa, and delta V structures also. We saw some SCADA based architectures like zone based models. So now I think if you see this zone based architecture, you will understand why these zones are there. So to check what type of communication is happening among these zones. Then we also saw about the building automations. It might be new for someone that if you have not worked in building automation, but now you have knowledge of building automation, like it has a one air handling box, then we have batch reader, we have access controller. So this is how it looks like. Now you understood that BACS, building automation, is also an OT. We studied about SIS overview. So why SIS is so important, why it is so critical. That's why triple redundancy is there. We also got to know about the IoT systems, IoT overview. So what is edge computing? When it comes to the computing, it is spread over the complete network from bottom to top. So that's why the computing is distributed on the complete network. That's why it is called edge computing. Then we learned about the Purdue model. So it starts from the level 0 and goes to level 5. Sometimes we keep safety zone as a separate. Sometimes we keep, if there is only SIS system, then we keep safety critical systems in the level 0 also. What is the requirement of these levels? So similar type of cybersecurity controls you can implement on a single level. Then we studied about how OT is different from IT. We went through the performance requirement, we went through the availability requirement, we went through risk management requirements, we saw system operation requirements, we saw resource constraints, communications, change management. So we went one by one through all the topics, and we understood what is the real difference between OT and IT. So now if someone asks us, we have plethora of terms, we can quickly make him or her or them understand what is difference between. Then prior to moving to cybersecurity, we tried to learn about the cyber attacks, what happened in our history and what was the causes. In some cyber attacks were very simple, it was very simple. Some attacks were quite advanced, so a special malware were designed to attack. So this is how we understood, like from old age to latest cyber attacks, like colonial pipeline also we studied. Then we saw what could be anatomy of cyber attack. So once we understood the attack, then we tried to understand what components we need to secure. So once we understood that what components we need to secure, then we need to understand how these things can be secured. So we should go for the defense in depth principle. What is defense in depth principle? By putting a multiple layer of cybersecurity features for each level, we can create a really defense in depth architecture, which is tough to penetrate by the adversaries, which will need a very high resource and compute power and skill to invade those systems. So if it is a pretty well designed with defense in depth principles, then we saw a sample network architecture and also the common zones. Like basically in OT we keep manufacturing zone, cell security zone, then we have enterprise zone also for the IT communications for business purpose requirement. Once all these things base was done, then we studied about the foundational requirements as per 62443. So there were 7 requirements. First was like identification and authentication. We learned about what is the identification, what is authentication, then types of access control. We also learned about the use control, what is the purpose of use control. So some examples we studied here, like non-reproduction, time synchronization, auditing requirements. Then we moved to the FR3, that was the system integrity. So whenever integrity or confidentiality comes into picture, it is all about the encryption. So we learned about 2 types of encryption, symmetric, asymmetric. Then we learned about what type of encryption and where we need to implement these things. So then data confidentiality, it is also about the encryption, and there are other things like restrict access to data, implement data retention policy, then develop and implement a cybersecurity program. So all these are part of the data confidentiality. Then we read about the restricted data, where we understood about the segmentation, network segmentation, why we do segmentation, what components are required for doing network segmentation. We learned about the firewalls, VLANs. Then timely response to event is the another FR. We learned about continuous monitoring, how we can generate those logs and or events. Then we can create a system which can do the timely response as well. And last FR was the resource availability. So here we talked about to enhance the availability of the system so that it can defend any of the denial of the service attacks as well. So resource availability we studied. Once it was done, then we went to another module. That module was about the basic technologies what we can implement. So started with asset management, then we studied about segmentation. In segmentation, I think we studied 2-3 times segmentation, so now it is clear for everyone. Then we learned about network discovery, why it is important and what type of protocols are used in network discovery technologies, like basically ICMP, LLDP or SNMP. Then we learned about the intrusion detection systems, types of intrusion detection system, type of detection mechanism in intrusion detection system, difference between IDS and IPS. So IDS is installed in a sideline in a parallel, we can say, but IPS installed in the series. We learned about the secure remote access. So what type of technologies we can use for secure remote access, why it is required, what it reduces. It reduces MTTR. Then we saw one example from Clarity. We studied about SIEM solutions. We studied what is the purpose of the SIEM solutions, or what type of roles a SIEM solution handles. Then we studied about SIEM, like how it can work, what is agent deployment. And finally, we studied about the endpoint protection, what type of endpoint protection is there, how the system matured in the evolution journey, and now it is quite mature. So this is how we completed our course, and I think it enriched your knowledge to a little bit at least. So now your task is to just keep on learning these technologies, keep on trying, reading the books. You can always go for finding the new things related to asset management or related to intrusion detection system. So we need to upskill ourselves, we need to learn things, we need to keep on applying, create a virtual machine, deploy these solutions. Virtual machines are also free of cost, available using VirtualBox. You can install Windows Server, Windows 10, see, learn about Active Directory, learn about patch management solutions by WSAS. So we need to now do hands-on experience, hands-on learnings also. We need to learn about the standards like IEC 62443, NIST 882. Go search on all the platforms nowadays. Knowledge is available everywhere. Once you learn these things, start including in your resume, and start building concepts about that, start building principles about that, and then try to learn wherever you get opportunity. Try to include cybersecurity aspect whenever you speak about something. Try to add cybersecurity aspects. Try to think with the cybersecurity aspects about, because nowadays cyber warfare has been becoming very, very, very fierce. And if you see the current state of the world, there are many cybersecurity acts, cybersecurity intrusions or cyber attacks are happening on the critical infrastructure. So that was the motive of this course, to increase the awareness of cybersecurity, at least to understand what is the cybersecurity for industrial purposes. So I wish you good luck for your career and journey. So let's wrap up this course. Thank you everyone. Have a nice time ahead.